All right, good morning, everyone. Thanks for joining us this morning in the Prairie Organic Vegetable Production Online Mini Conference. This is the second online mini conference that Sask Organics has co-hosted, and we are really pleased to have partnered with the Organic Agriculture Centre of Canada for this year's event. My name is Deb Tuschelt, and I am the Programs Coordinator with Sask Organics. With guest speakers from across the country sharing their expertise on a variety of topics, I think there's something for everybody in this program, whether you're on the prairies or not, whether you're a certified organic producer or you're just interested in organic production methods. Because our speakers and hosts are in different time zones across the country, we had to pick a time that worked for most. So we apologize to those of you on the West Coast that it's a bit of an early start for you. Before I introduce our first speaker and turn it over to him, we are just going to go through a few quick slides. Just ensure that you are muted while the presentations are in progress. There will be time to answer questions from the audience after each presenter, but feel free to type them into the chat as you think of them, and we'll do our best to answer as many of them as we can. During the question periods, attendees can ask questions using the chat function or verbally. And if you wish to ask a question verbally, just use the raise your hand function, and then we'll call on your name and unmute you. The meeting is being recorded, so if you're not comfortable having your voice or webcam recorded, just use the chat function. In order to fit as much content as possible in this short half-day event, we don't have any scheduled break times, so we do encourage you to just stretch, take breaks, grab a beverage as you need, and if you miss something, you can always catch it on the recording, which all attendees will receive within a day or so of the event. And there is time for some networking built into the end of the program. And finally, please bear with us as there are sometimes technical glitches with any online event, and we will do our best to make it run as smoothly as possible. A little bit about Sask Organics. For those of you that don't know about us, we are a nonprofit, farmer-led membership organization representing all the certified organic operations in Saskatchewan. And some of the work that we do is education, events like these, promoting research that reflects the needs of organic producers, advocacy, market development, and promoting organic agriculture with producers and consumers alike. And in the graphic there, you can see this is just some quick stats from 2020 organic production in Saskatchewan. You can see that we had about 1,025 organic operations total. The majority of our organic acres are, of course, in organic field crops like grains and pulses and pasture acres and forage, but you can see that we had 1,569 acres of certified organic vegetables and fruit in 2020. And with just over 1 million acres in organic production, we represent 29% of the land under organic management in Canada. So next, I'm going to turn it over to Andy Hammermeister of the Organic Agriculture Centre of Canada to tell us a little bit more about them and the work they do.
Great. Thank you very much, Deb. It's so nice to be here, part of this event. I'm originally from Saskatchewan, and so my heart is still going out there. The Organic Agriculture Centre of Canada is located in Nova Scotia as part of Dalhousie University's Faculty of Agriculture. We've been around for 20 years now, and always trying to serve the national science interests of organic agriculture. And so we work very closely with the Organic Federation of Canada to deliver the National Organic Science Cluster Program. That's kind of the big project that we have going on right now. And there's a few links here that you can go to, but we put out a lot of information and resources relating to organic science in Canada. And if you'd like to sign up for our free newsletter, just click on the SKU there or take a photo of it, and you'll be able to sign up and get all of the updates when we send out new information. including our Organic Science Canada magazine, which summarizes our organic research. But you can access that through our website as well. So we're very much looking forward to this event, and we've had a number of projects under the Organic Science Cluster that have dealt with vegetable and greenhouse production systems, not too many in the prairies, obviously. So looking forward to participating in this event. Some of the researchers that are participating in this event are also researchers within the Organic Science Cluster program or have been in the past. And with that, I think I'll pass it on. And maybe Macy, do you want to introduce yourself very quickly to the group?
Yeah, sure. So my name is Macy Penny Cameron, and I'm the communications officer. I work here alongside Andy at the Organic Agriculture Center of Canada.
Great. So with that, I think we'll pass it on and not hold up the show any further, Deb. Thanks.
Okay. Thank you very much, Andy and Macy. Going to acknowledge the sponsors now of this event. Our gold sponsor, Grain Millers Canada. Grain Millers is the world's largest organic oat processor and produces about a quarter of all the oats in North America. And while they don't process vegetables, they are a great supporter of the organic sector in Saskatchewan, and we're grateful for the support of this event. And our second gold sponsor, Johnny's Selected Seeds. Johnny's offers a large selection of certified organic seeds and plants for the commercial farm or home garden, as well as OMRI-listed growing supplies such as fertilizers, etc., approved for use in certified organic crops. And our other gold sponsor, West Coast Seeds. Since 1983, West Coast Seeds has sought to meet the growing needs of home gardeners and market farmers alike. Now under the stewardship of the Diamond family, they continue to provide the highest, freshest quality untreated seeds for organic growing. And thank you to our silver sponsors, ProCert Organic Systems and EcoCert Canada. Both companies offer organic certification services, as well as a variety of other certifications to suit your needs. And we are grateful for their support of this event. And lastly, Sask Organics is able to host events like these and co-host events like these thanks to the support of the Prairie Organic Development Fund and their sponsors. POTIF is funded through the Canadian Organic Ingredient Strategy by the Canadian Agricultural Partnership and the Government of Canada. And now we move on to what brought you all here today, our guest speakers. And our first guest speaker is Dr. Yubin Zhang, here to speak to you about his research in high tunnels in cold climates. Dr. Yubin Zhang is a professor of horticulture science at the University of Guelph and the president of the Canadian Society for Horticultural Science. He has more than 25 years experience in controlled environment, CE, example, greenhouse high tunnel, production of high value plants, conducting research, teaching, and providing advice both to growers and government agencies. He and his team have extensive experience in CE production of organic vegetables, medicinals, and berries. And he's the editor of a recently published textbook, Handbook of Cannabis Production in Controlled Environments. And Dr. Zhang has been frequently invited to speak at industry and academic gatherings, both locally and internationally. And in his spare time, he's also a hobby grower with many years experience growing different varieties of vegetables and berry crops organically. So with that, I'm going to welcome Dr. Zhang and stop sharing my screen, and I will turn it over to you.
Good morning, everyone. I'm trying to get this working. As Deb said, there are sometimes technical issues. Shouldn't take too long. Yep. Deb, can you see my screen?
Yep, we can see your screen, and I think if you just press the slideshow mode, then we should see it in the full screen.
Okay. Do you see the full screen now?
Nope, it's still in the presenter mode.
Okay, so I need to stop sharing and then share the right one.
If need be, we can, it's fine the way it was, if that's what we can, all we can do.
It should be easy, but that's just my, yeah. Oh. Oh. I'll just talk amongst yourself. I should be ready very soon. Desktop 2.
There we go. Yep, you got
Yeah.
it.
Wonderful.
Perfect.
Yeah. Well, thank you very much for the introduction, Deb, and thanks for inviting me here. A few years ago, we did a research project looking at using high tunnel to produce organic vegetables. And then based on that research results and my personal experience, I believe that high tunnel may be used for high quality and yield organic vegetable production in the Prairie. I say may here because I only been to Saskatoon once, gave 2 talks over there for a day, so I came back. So probably some of you already using high tunnel. So we should change this to can be used, but you will tell me when we talk through this, and you're welcome to provide inputs. And then, so here you can see from the sky that we build 6 high tunnels, and then we also have 3 fields, open field and control. As you know, scientific research, we have to have replicates. So the 6 high tunnels, 3 of them we have insect nets, 3 of them we don't, just to see how effective or what insect net will do to the crop. So here is a closer look of the 6 high tunnels. And here you see these are the field, open field used as control. Those are high tunnels with insect nets here. Those are the high tunnels without insect net. Those are, here is the door for getting in. Well, I'll tell you the conclusions of this research is basically we feel that, well, the results told us high tunnel can improve crop yield and quality. We think they are due to extended production period, both early spring and late fall. And then it can reduce yield loss from disease, animal, and severe weathers. The severe weather, including heavy rains, and then also even not severe weather, for example, when we grow plants in the field, quite often the leaves are wet after the rain. And then when the leaves are wet, they normally invite disease. In high tunnels, you don't have that issue because there's hardly any rain on the leaves. And also you create a better microclimate for the plant production, which I'm going to mention to you a little bit later. you can grow specialty crops, which are difficult to grow in the field. There are many, which I'm going to mention a few. So really, we found that the plants in the high tunnels are doing much, much better than in the field. Here are some examples. This photo was taken in July 23rd. This is in the field, the tomato crop. This is in the high tunnel. You can see the fruits here already ready for harvest, but here still green. And another one I want to mention is bitter melon. The fruit is like this, like bumpy cucumbers. Why we grow bitter melons? Bitter melon are consumed by many people, especially in Asian countries, South America and African people. And they have lots of medicinal values, especially good for type 2 diabetes. In Canada, we spend more than $10 billion per year on diabetes patients. But this you can eat as vegetable, but in the same time may contribute to the control of type 2 diabetes. But then the thing is that it's too cold here. If you grow them in a field, the yield is very low. But if you grow them in high tunnel, you may be able to. I'm sure some of you probably never heard about this crop, but some of you been consuming. You can buy them from groceries, but they are all imported. If you are using them as medicinal or nutraceutical, it's better to produce here locally. I'm going to mention a little bit more about this crop down the road. So here you can see cherry tomatoes in the high tunnel, that's in the open field. And then for the high tunnel itself, we have, as I mentioned, we have high tunnel without insect net, and then high tunnel with insect net, and then that's the open field. So you can see the tomato fruit harvested, how many kilograms per plant. In an open field for that tomato, it's less than 1 kilograms. But in high tunnel, it can reach as high as 4 kilograms per plant. I just want you to remember here, the high tunnel with insect net, the yield was a little bit lower than without. We think probably sometimes tomato plants don't like too hot in the high tunnel, but we'll keep that in mind. And then here is the bitter melon. You see that is ready for harvest. That's in the field, still struggling to catch up. And if you look at the fruit numbers per plant, that's in the field. It's less than 2 fruits per plant at the final harvest. In high tunnel with insect nets, you got about 18 fruit. And also you can see that the yield per plant in the high tunnel with insect nets is about 2 kilograms. But in the field, open field, it's only 0.2 kilograms. One thing I want to bring your attention here is the high tunnel with insect net here for bitter melons did much better than high tunnel without insect nets. This is opposite from tomato. You see, the yield was lower with insect net, but bitter melon was higher. So you can see that if you just ask in the question, is insect net better for high tunnel crops? And then the answer is it depends on the crop. If the crop needs high heat, yes. Otherwise, it's not necessarily. Then that's some of the results. Now I'm going to talk about the lessons we learned. This is going to be quick because I just summing up some of the things, so not that much data. The first thing is that high tunnel, the design and then the material is very important. Otherwise, you got wind damage, snow damage. We didn't have these issues, fortunately, but this photo we took, some of them, we visited some high tunnel operations here in Ontario before we built ours. Ours, when we built it, right away, before we got crops in, we had a storm with wind speed 110 kilometers. But ours survived very nicely. So the design material of ours went well, lucky. So if you are planning to build high tunnels, be careful about the material and then the design. Talk about design, and then also you want to think ahead that what kind of machineries you are going to use. So if you are going to use big tractors, so the door has to be much larger. And also you can see here, this high tunnel has fans here. If you have hydro electricity around, those are great to have fans because in the middle of summer, the high tunnel can be very hot. Even I strongly suggest that we design high tunnel with this side vent, like here. For ours, we put insect net as one treatment, another one without. Or if you have solar power, you can have these fans. Otherwise, the environmental management can be a little bit more difficult, but doesn't mean you cannot manage it. Like our high tunnels, we don't have fans. We didn't have any hydro over there. And then also, if you don't have big machines, you're gonna use tillers like this, and then you can have much smaller doors, and it's much cheaper. And again, this is our high tunnels. We have here open during summer, and some of them have insect nets, some of them don't. And another good design we would suggest is that use the roll bar like here. You can roll the plastic up when you need to cover the high tunnel, but early spring or in the winter, you can roll it down. So the plastic is rolled, stored on site, and it's neat, clean. And then early spring or winter time, you can let the snow come in and kill the bugs, everything. But in the spring, you just roll it up. We found this design is very useful. One cautious thing to remind us is that, because we have high tunnels here, and then the rainfall on them gonna fall on the ground. So even a little bit of rain can be a lot of rains. So we strongly suggest that you have drainages around. You can build a pond so you can collect water for future irrigation. And then also sometimes the water table is too high. It can get a little bit muddy if you don't have drainage around. Even, if you have a high tunnel, before we did this research, we thought, well, high tunnel probably able to protect the plants from frost in the early spring and later fall. but not necessarily. These high tunnels, they do increase temperatures, but when there's very cold weather, they still can damage your plants. So we have ground cover, and then also we have here, you can see that we have high tunnel here. Before we had frost in the spring, we covered it with a black plastic or white plastics. And then here you can see that that's the air temperature. Air temperature in May in the morning is dropped below 0. But if you have these white plastic, and then that's the line, it's increased a few degrees, certainly above 0. And if you have black cover, it's increased even more. It's increased more than 7 degrees. So keep in mind, only one layer of high tunnel plastic may not be able to protect some of the killing frost in the early spring. So inside, it's good to have another layer in case you need it. In the fall, as well, in Guelph, probably in your place as well, normally we get a killing frost, 1 or 2, early October. And that's what happened. Early October, you see the fruits were still very great, wonderful, many kilograms in the greenhouse, but just one killing frost, all get killed. And as I said, early October, you have that killing frost, but normally just after 1 or 2, and then the weather become better. So if you have another layer somewhere to protect these crops, and then your yield will be much higher. One layer is not enough. This is bitumen. And even it's not like greenhouse, which is more controllable, but it's too expensive. High tunnel, we still suggest that you use environmental monitoring devices over there, and it's measure your temperature and humidity so you can manage the environment. For example, if you have fans, you can decide whether to cool or not. And so you can see that I mentioned to you that the microclimate in the high tunnel is much better than outside. You can see over the season, the field temperature average is 19. If you have a high tunnel, it's increased 1 degree. If you have a high tunnel with screened, you got a 2 degrees increase. And then if you calculate the degree days, the unscreened high tunnel got more than 100 degree days more. And the screened got about 260 degree days. And also here you can see the temperature that's in the field, that's without screen, that's with screen. So it's increased the temperature, especially in the early and late season, which are very good for plants. And with the insect net, I mentioned that the insect nets can increase temperature, but also we use them, the main reason is to keep the insects outside. So insects outside, you will have less disease. You see, we used blue traps and yellow traps. In the field, we trapped that many insects for the blue, that many for the yellow stick traps. And then inside of the tunnel without insects net, the number of insects reduced to half. And if you put high tunnel with net, and it's reduced to 1/10, so it's quite effective. Another nice thing I we learned is that we need to open to more vegetables and production strategies. When I say more vegetables, so it's not only tomato, cucumber, and sweet peppers. We have a diverse population here. Many vegetables are very good, healthy. And so in our trial, we tried to grow edible chrysanthemums and pea shoots and pea pods. And then we got very good results. For example, you also can do intercropping. For the edible chrysanthemums, you have, when you grow either tomato or bituminous, it's gonna take this vine crop quite a little bit of time to be grown up for producing fruit. During that time, there's empty space, so you can intercrop these vegetables for short term. They are ready for harvesting, so you got extra income. So you can see here we have pea pods, and per square meter we use high tunnel, we could get about 800 grams of pea pods, but in the field you only get half of it. Pea shoots as well, it's delicacy. Probably now, if you go to supermarket to buy, they would be $8 a pound. So we used high tunnel to grow them. You can get about 100 grams per square meter per harvest. And another thing I want to, I noticed this is another trial. I grow vegetable in my garden as well. And so this year, this is not a scientific research, is that we had minus 15 degrees cold. And then afterwards, a few days later, I went to my garden. These plants were still survived very nicely. So that tells you that there are many vegetable, especially leafy vegetable, brassica type, they can tolerate cold. So if you have a high tunnel over there, and then you can probably harvest them even in December. And then also, of course, kale and spinach, they can tolerate cold as well. But those two photos were not taken by me, unfortunately. Use high tunnel, you can really improve your quality and yield, because you can prevent all of this damage from weather, animal, and disease, as I already mentioned. And I feel that, I had a look of your temperature here, the highest temperature, and then the lowest temperature. I really feel that, use high tunnel, you're probably able to start working on crops in March. And then also, as I already mentioned, that some of the crops, probably you could keep it until December, and not tomato though, for sure. And this work not only done by me, of course, that was me when I was younger. There were lots of people contributed to this research. So I'm not gonna mention their name here. I think my time is up. And then I would like to thank Agriculture Agri-Foods Canada for supporting this research through the Organic Agriculture Centre of Canada, Ontario Ministry of Agriculture, Food and Rural Affairs, and Biofit Manufacturing for supplying all my fertilizers, Decloid Greenhouse for helping us build the high tunnel. And then also we have technicians and students, and thanks for them for their. And finally, I would like to thank you for your attention. Oh, this and is a recording. If I have time, I can. And here is my questions. Contact information. And here and thank you very much. And
all right, thank you very much, Yubin. again, welcome to type questions into the chat. We did have one question and a comment so far. Somebody asked, I have high tunnels on my property where I also have a high water table in the winter, and it has resulted in a salt deposit as the water evaporates, resulting in incredibly high EC levels. Do you have any recommendations on how to deal with that?
I think, first of all, thank you for saying that. Now we can change my title from May to Can. Another thing is that the high salt issue, probably one is from your drip irrigation or whatever the way you water them, then will wash down some. And then also winter time, probably the best is if you can open the top, just open it. And then you'll have winter, you have snow, and early spring, you got rainwater to wash them away and then drain out. And another thing is that probably just analyze your soil nutrients just to see what is high, so you don't supply that much to save your fertilizer. Other than that, I don't really have any better suggestions, but thank you very much.
Okay, great. Would just out of curiosity, would building up, if you wanted to sort of raise some beds in the greenhouse, would that also possibly work?
I think that's a very good idea, because many crops you can hail it up as well. Yeah, and the plants do better.
Okay, great. There was a comment more, and Shungiku likes the cooler summer weather and grows very well for this person. I'm not familiar with that plant, but it was just a comment. So
yeah, thanks. Yeah, we should explore to find more plants to grow. As I said, not only tomatoes and sweet peppers, there are loads of leafy plants if you grow them, and people will buy them. So I visited quite a few organic vegetable farms here. They are very small. In a way, we really need to utilize our land so we can do intercropping and a few crops per year sort of thing. So.
right, okay. Yeah, and somebody commented if you have any other suggestions for novel crops in high tunnels, they welcome it. I think as you pointed out, that's kind of the opportunities are endless in terms of, you know, how we can really expand this kind of production, especially on the prairies. But
yeah, I think salad, for example, mixed salad, and many people organic. If you go, especially if you know your population around you, if you create that market and then you produce organically the baby greens, all of this take short time. And in high tunnel, that's a very good opportunity. But you can mix different leafy greens and organically. I don't think we have that many here. I work with an organic greenhouse here, and their product just very popular. Their organic baby greens, they can just harvest without washing and put into refrigerator, last you for 40 days. I never knew that, because in the past when I buy from groceries and they are imported a week or two, they are gone. So if you guys can look into that, I think your people around you will thank you.
right, okay, and then and Andy from the OECC commented that salts can only be really removed by washing them out of the soil. Putting mulch over the soil surface stops evapotranspiration and prevents salt buildup, but make sure your irrigation water has low salt too. So all good points.
I do have a question for you, Ben, if I may.
Sure, Andy.
I think you made some really great points around the protective structure, and it helps to prevent disease spread by reducing rainfall impact and splash effects on the crop. And Deb just mentioned raised beds, and so when do you recommend using raised beds as opposed to just a flat surface within a high tunnel system? Like you were showing your tillage equipment, and so either a bigger tractor or a BCS tiller type walk behind. And when do you use raised beds, and when do you just leave the ground flat?
I think if you have time, and it's always better to have raised beds, because then it's easier for you to walk along, and then also the soil will be much deeper and easier to work with. And especially there are some unique crops they like to have deeper soil as well. Because I think I should know a little bit more, but I don't, because my research are mainly soilless production. And we did this research was just looking at high tunnel, how does it work? That's why when we build this, start to work on it, and then the spring, the high water table, and no drainage. The first year we were, yeah, what's going on here? We never experienced this, because my research all greenhouses use soilless, so we don't work that much on that. We formulated lots of organic soilless media, but those are in parts we can control the irrigation. So I don't think I have many good answers for that, Andy, but probably you have more experience because you've been in this field for many years.
Not many answers today, but I'm sure we'll get some from other speakers. Thanks.
Yeah.
All right, we did have a couple other questions come in here. Do you have any comments regarding comparison of high tunnel opportunities in northern Canada versus the prairies?
No, we just did this work in Guelph, and so that's why the title for this I even put May. But I feel the main thing is that if it is too windy, it can be hard. And then also if it is too cold, it may not protect. But I just mentioned high tunnel. There is another technology, probably you guys know, is the Chinese sauna greenhouse. So what they do is one wall is mud, very thick wall, and then another side is the plastic. And then so when it's cold, you close that, the sun comes in, heat up the wall, and in the night, you just cover that plastic, and then the heat stored in the wall coming out. So that will increase the temperature in the air quite a bit. Like in China, they've been doing this very north. And some of the places I went to, they are really very cold. And some of the places as in Alberta. But then that's the construction would take much longer, more effort for sure, because you have to build that wall, mud wall, and then also a blanket just to cover it. But for high tunnel, I think even many parts in Canada, we can use high tunnel. Just a layer of plastic increase your tomato yield by 4 times. I think that's worth it. And then also the quality was really much better because you don't have disease or any insects damage on them.
Great. Yeah, I was actually going to ask you if you had any knowledge about, I think they're called Wallapini greenhouses, and the design you just described sounds similar. We're kind of they're dug into the ground or partially dug into the ground, and they use that. So yeah, I think that's interesting. I don't know if anybody has any experience with trying those, but it's a design that interests me. Do you, so how long, I think you might have covered it in a slide there where you took the average temperatures of Saskatchewan, but how much longer in Saskatchewan do you think that you could extend the growing season?
I feel your temperature is not that much colder than Guelph. I thought it was much colder, but when I look at that average weather data, it's not that much colder. And then so in that case, I have a feeling that you probably even able to harvest some of the crops in December, but not tomato, this type of subtropic plants. Like if you grow kales and some of the cabbages, not the cabbages, cheap cabbages, but the cabbages with higher values, and they can tolerate -15, like in my field, in my garden, I experienced that. And people can look into the internet to see what crop to grow and then how cold they can stand. You really, I have a feeling that some of the places for some crops, you can even harvest towards December. And then, of course, January, February is too cold. And then also you give the land a little bit of break by open up, kill bugs, and then also let the snow come in. Probably that's a good idea. But then in March, you could start to cover it up. And then, because I don't know in your place, but in Guelph, in March, we start to get lots of sunshine. When you get sun, the temperature inside will warm up. But again, as I mentioned, that only one layer may not be able to protect the plants from frost. Sometimes you do need to have 2 layers. We saw quite a few commercial high tunnels. They do have 2 layers inside for certain crops.
Right.
I think I rushed into a little bit because I was messing around, couldn't get it work. So when I talk, I was fast. I said, oh, I don't have time. Looks like I got plenty of time. It's a good thing though, is if you are interested in, you can email me because we published a few papers. Some of the details, I can send you the paper, you can read it. Open it up this way, we can have a conversation because I know you guys, including me, sitting there, listen to people look through data can be boring. So I'm happy to have a chat with anybody who wants to.
Well, that's great. Yeah, and no, it's great. There's still some questions coming in, so we have plenty of time here still. We got about 5 minutes left. So, how much insect pressure and disease do you feel was related to inferior or superior growing conditions for the bitter melon?
Or the insects for bitumen itself. This crop is not that prone to insects, actually. So the main thing for bitumen is temperature. And so you see here, we have that insect net. The temperature was 2 degrees in average, higher than in the field. But of course, in summertime, it's even higher. So the yield, the higher yield with insect nets for bitumen is mainly caused by the temperature, because I've been growing this crop for quite some years. I think it is more than 15 years ago. I feel we should grow these crop here. So I introduced these to greenhouse productions here. So we had a greenhouse here, grow these, and some of them grow in the field. This one doesn't have that much pressure from insects. And then also here, I just want to say this crop, it's because even you are able to grow them, and when you grow them, produce them, they get sold very quickly. But why we still don't have a greenhouse to produce them here in Canada, the reason is that cucumber is much easier to grow. And then also everybody eats cucumber. So people just hesitate to switch. But if you want to grow this crop, it still can be sold quickly.
Great, thank you. And there was just a couple comments in there. Looks like there's somebody provided a link to greenhouse in the snow and that they're installing one as we speak, but not complete yet. And they will keep us posted. That sounds interesting. Great. Oh, I think I did miss one question here. Do you have any suggestions for low tunnel?
I don't have that much experience on no tunnels.
Okay.
We use in my garden with no tunnels. That's good as well, but that's more for certain crops short term, and then you can cover it and open it. So it's a little bit difficult to operate inside. High tunnel, it's easier to operate, and you can build it, and you can use machines, this and that. And then also, especially if you grow tomatoes, the tomato I showed you, these tomato cultivars are for greenhouses. So they are indeterminate. So high tunnel, you can grow them from the spring to the end of the season and then continuously harvesting. But low tunnels, you just can't do that. But then leafy greens, certainly it's cheaper and easier to grow.
Right.
Thanks.
Great. Well, thank you very much. I'm not seeing any other questions or comments come in. So thank you so much, Dr. Zhang, for presenting to our group today. We really appreciate it.
Thank you for having me.
Thank you. And so now I'm going to turn it over to Macy Penny Cameron. And I'm just going to share my screen so she can read out the bio of our next speaker.
All right, thank you, Deb. So our next speaker today is Tiara Stokes. Tiara is the Prairie Regional Coordinator for the Bauta Family Initiative on Canadian Seed Security. Tiara first fell in love with the world of food systems as a summer student with Organic Alberta after graduating from Mount Allison University with a Bachelor of Arts on honors in politics and economics. Tiara rejoined Organic Alberta, where she worked on developing farm clubs in Alberta, a soil health toolkit, and a curriculum for organic growers, and managed the Pilot and Grow website and resources. As a regional coordinator, Tiara is committed to supporting growers in the seed community and creating a resilient seed and food system. Thank you. And we are going to turn it over to you, Tiara.
Awesome. Thanks, Macy. Thanks, Deb. It's so great to be here. I'm really excited to talk to you guys about canola and participatory vegetable breeding. I'll just get my screen up. Everyone can see that? Okay.
Yeah.
Awesome. So yeah, hello again. So great to be here. As Macy said, my name is Tiara, and I'm the Prairie Regional Coordinator for the Bauta Family Initiative on Canadian Seed Security, as well as a program manager with Organic Alberta. And today I'm joining this mini conference from my home office on Treaty 6 land, which spans across Alberta, Saskatchewan, and Manitoba. I live in a community just outside of Edmonton, and the sun is somewhat coming up here. Hopefully it will be by the end of the presentation. And here I'm neighbors with the Alexander Cree, Nakota Alexis Nokotosu, Enoch Cree, and Paul. And today I'm going to be talking to you about the Kenobi program and participatory vegetable variety breeding. I'll also spend some time highlighting what we've learned from farmer research collaborations and genetic environmental interactions in our organic variety trials. So what is Kenobi? Kenobi stands for the Canadian Organic Vegetable Improvement Program, and it's a national program that works with farmers, seed growers, research institutions, and farmer-led supported organizations across the country, with the goal to increase the quality, quantity, and diversity of organic and ecological seed adapted to Canadian farming conditions. We run a range of different programs and work with a host of different farm organizations across Canada to support on-farm research and training on seed conservation, seed production, and plant breeding. Kenobi is a partnership with the University of British Columbia and land-grant universities in the US, and is also funded in part by the Organic Science Cluster 3, which is a funding program at Agriculture Agri-Food Canada. So why did BATA start this program called Kenobi? Well, virtually all vegetable seed planted by Canadian vegetable farmers has been bred elsewhere, and virtually all the seed is grown outside of Canada as well, meaning that none of these varieties have been bred or adapted to Canadian farming conditions or climates, or being produced at scale at vegetable seed companies in Canada. We know that seed selection is a very useful tool for organic farmers to buffer against environmental stressors. Organic crops face challenges from weeds, pests, diseases in increasingly complex ways, and face different selection pressures than conventionally bred crops. And we know that climate change is real, and as seed shortages brought on about by various environmental, economic, and political situations, it's important to have regional seed if and when you're trying to find varieties that work for your climate. This is where Kenobi steps in to support farmers in regional seed breeding and variety trials in Canada on Canadian farms, ultimately to support regional adaptation and seed security, which we have outlined here. So the purpose of plant breeding, as we know, is to develop a new variety. And in this chart, we can see a few different methods of plant breeding. Just to quickly overview the chart, the F in the column stands for when a farmer is involved in this research process, and in the breeding process, and the R stands for when a researcher is part of the breeding process.
Tiara,
and so if we look,
sorry to interrupt you. We're just still seeing the opening slide.
Oh, okay. I hope it was a good one. Here, I'll try I'll stop sharing my screen for a second. Oh.
Maybe it has to do you have two monitors?
Yeah, maybe that's it. Okay.
Okay.
Can you see it?
Yeah, now we
Okay.
can see the one that you were just speaking of.
If I flip back, can you see a new slide?
Yes, yeah.
Okay. Perfect. Okay. There wasn't a whole lot going on in those other slides, so that's okay.
Okay.
This is a more important one to see the slide, so that's good. So yeah, here we have this chart which outlines a few different ways that plant breeding can be done. So yeah, again, the F in the column stands for when a farmer is involved in the research process, and the R stands for when a researcher is involved in the breeding process. So for example, in the grassroots model, we see that for identifying breeding goals, both the farmer and researcher are involved in this process. However, when it comes down to something like variety evaluation, just the farmer is involved in this process. So as we know, in any breeding program, the steps to create and release a variety are all the same. You have to have some breeding goals in mind, so you know what kind of variety to develop, and understanding what varieties you'd like to use as parental lines to create genetic variation. And then you have to take that genetic material through the stages of selection and evaluation before it can be used on farm. Historically speaking, those activities would have been done by the farmer. So we see here on the traditional column where the farmers just checked off as being involved from breeding goals all the way to variety registration. However, as agriculture industrialized and plant breeding became more private, farmers were less involved in the process of commercial variety development. And we can see that here in conventional, where it's the exact opposite to traditional, where it's just the researchers who are involved in the breeding process. Although this isn't how it always works out in practice, what we're aiming to do is this complete form of practice where the farmer and the researcher are collaborating and involved from breeding goals all the way to variety release. We aspire to work towards this in the spirit of empowering farmers and ensuring that they are deeply involved in the variety development and variety trialing process. And this collaboration is important for a few reasons. First of all, on-farm evaluation allows for more accurate representation, the broad range of environmental and cropping systems, characteristics of organic farms. Research knowledge and capacity allows for larger data collection and statistical analysis. Additionally, research in multiple crop species has found that organic agriculture is distinct from conventional agriculture as a selection environment for plant breeding, and that the direct selection in organically managed environments will result in higher yielding varieties than would indirect selection in conventional environments. There's a great paper called Adaptability Analysis in a Participatory Variety Trial of Organic Vegetable Crops by Alex Lyon, who is a previous Kenobi coordinator. And Alex and her co-authors illustrate that broad adaptation through multi-location trials like Kenobi are really important for organic plant breeding. I'll just put the link to her paper in the chat so you can take a look at it, and we'll kind of quickly touch on this paper a little bit later as well. So in our Kenobi program, we've aimed to include farmer and researchers in the process of breeding and variety trialing, balancing the strengths and barriers that each have. And this design includes an incorporation on-farm evaluation consisting of signal replicates on each farm and replicated research station trials, allowing for robust experimental design while minimizing time requirements for farmers. So for a lot of the vegetable research we're trying to support here in Canada, we draw on models that have been developed by the US for organic vegetable farmers. There are two programs I'd like to just highlight here in the States. The first one is the Northern Organic Vegetable Improvement Collaboration, or NOVIC, and the second one is the Carrot Improvement for Organic Agriculture Program, or CIOA. And so to begin, NOVIC was a variety trialing network set up across several land-grant universities, including Oregon State University, University of Wisconsin-Madison, Cornell University, Washington State University as well, the USDA, and an amazing nonprofit organization called the Organic Seed Alliance. They focused on crops including bell peppers, sweet corn, winter squash, tomatoes, and cabbage. And CIOA, or the Carrot Improvement for Organic Agriculture Program, is led by University of Wisconsin-Madison and a whole bunch of other collaborators. And they focused on developing orange and novel colored carrots with improved disease and nematode resistance, improved weed competitiveness, and improved nutritional value and flavor. The other major point of inspiration for this project has been this incredible group of vegetable farmers and seed growers in southwestern Ontario. You can see those four people there in the middle there. And they started a collaborative breeding project to develop a red bell pepper that ripens earlier in their climates. One of the central goals of this pepper, in addition to earliness, is flavor. And these growers, they've been working with chefs and their customers to help evaluate the flavor of the varieties that they're working on. And the first of the varieties was developed through the research and is called Renegade Red. And you can get it from Hawthorne Farm Organic Seeds, as well as Kitchen Table Seed House. So a lot of what we've been trying to do with Kenobi is lay the groundwork for these kinds of variety trialing and plant breeding networks to be set up in Canada. By drawing from the models and building off the amazing work, like the farmers here from the Seedworks Plant Breeding Club, Becca, Annie, Kathy, and Greta, we're hoping to follow in their footsteps in a way that prioritizes participatory research and gathers information to help develop high quality, open pollinated varieties, all in the hopes of increasing the regionally produced seed diversity available to organic farmers in Canada. So from 2018 to 2022, we've been running a bunch of different variety trials on bell peppers, orange and red carrots, radicchio, and rutabaga. These crops were chosen for a variety of different reasons, but it always came down to a combination of farmer choice, economic potential, and where there was existing breeding material or regionally produced seed to be evaluated. To gather information from farmers and from research sites, we used an app called SeedLinked. It's an amazing platform developed to help farmers record data on how varieties are performing on their farm and then updating that information in real time. One thing that was really cool that we've been doing over the past couple of summers is having variety taste tests with consumers where consumers can try the different varieties, scan a QR code, and do live results of what they think of the different flavors of carrots or radicchio. And so not only it's a good data collection and easy to use for farmers, it's also a really nice consumer connection extension piece. However, one of the limiting factors in doing participatory variety trials like this is gathering all the data at the end of the season and interpreting that data into reports in time to inform seed procurement decisions for the following season. We're still working on this timeline and hopefully we'll get better each year, but the level of work that SeedLink saves in the back end is tremendous and is becoming increasingly usable for farmers since the project started. One of the limiting factors for SeedLinked is that it's best for observational traits and not observational trials and not replicated trials. So varieties trials were set up as single replicated trials per farm, understanding that replication was happening among farms, and at hub sites there were 3 to 4 replicates of each variety. So for today, I'm going to take you through some of the 2022 Kenobi results. And here's just a breakdown of our participation in 2022. We've been doing this since 2018, so there are a few people who are new this year. Unfortunately, we didn't have folks from Saskatchewan and Manitoba participate this year, but we have in the past, and hopefully in this next phase, we will as well. The orange dots here are folks who participated in carrot trials. The purple are radicchio, and we just did radicchio in Alberta at the UBC hub site, Ontario, and then 1 or 2 farmers in Quebec. And then there was I had a lot of demand for a rutabaga trial this past year in Alberta. So we did rutabaga in Alberta and northern BC. And if you're interested in the overall results from this, you can go to our websites and we have, and I'll put that link in the chat afterwards, and you can take a look at a brief report, complete report, and webinars that our Kenobi coordinator, Solveig Hansing, put together on our 2022 results and from previous years. So one of the exciting things about the Kenobi program, being a national program, is that we can get some insight on genotype by environmental interactions. So how genes respond to different environments. Broadly, we know that genotype by environmental interactions exists for some traits in some crops, in both organic and conventional systems. And whether a given trial detects genotype by environment interactions depends on a set of cultivars trialed, the location used, trial size, and the way the trait is measured. That adaptability analysis paper, which I mentioned earlier, that Alex Lyon, previous Kenobi coordinator, put out, gives examples of cultivars that are broadly adapted. And as I mentioned earlier, Alex and her co-authors ended up arguing that broad adaptation through multi-location trials like Kenobi are really important for organic plant breeding. So today I'd like to take you through some of our 2022 Kenobi results to uncover what we can learn about genotype by environmental interactions and participatory organic vegetable breeding. This will be through specific traits that we found interesting, as well as what we can learn from opportunities that come from farmer and researcher collaborations. So in the prairies this year and Ontario, we had 18 participants take part in a radicchio trial to evaluate early maturing red radicchio varieties in organic conditions. Radicchio is a really interesting and fun crop that's gaining more and more attention in North America, particularly in the Oregon area, but coming more in Canada as well. Getting more interest from market growers because it has a hard leafy green and can offer some unique diversification options for CSA and market farmers. And it's also gaining more interest from chefs and restaurants. It's a long season crop, but there's not a lot of great quality open pollinated varieties that mature into full heads consistently yet. And this picture is from a farm in just outside of Calgary at Poplar Bluff Organics. Poplar Bluff Organics has been trialing radicchio for about 3 years now, and they did a larger trial, and it's been really interesting to see it grow pretty well in that region. So these are the varieties that we chose for 2022. These were selected based off of larger trials that we had in 2020 and 2021. These were the best performing varieties, as well as varieties that were shorter season. There are some varieties that are pretty long season that didn't work so well in the prairies. So here we have 4 Chioggia varieties, a Treviso and Verona, 4 open pollinated varieties, and 2 F1s. And again, we chose them also because of their shorter season. And as you can see, they're very beautiful and distinct vegetables. So all participants in the radicchio trials evaluated their trials using that SeedLinked app I mentioned earlier, and they submitted 1 to 5 ratings for traits like germination, vigor, appearance, and yield. So the way you can read this chart is it's coded in color. So the more green it is, the higher the score it is, 1 to 5. So this Pascalino 4.7 is very well. If it's in the yellow, that's a medium score. And then if you see red, which we don't see here, but we see a little bit of an orange, that is a poor score. We can see here that Pascalino is doing really well, and we'll come back to it a little later, but we don't have any statistically significant differences in ratings for any traits. This lack of significant evidence could have happened for 1 of 2 reasons. One, it could be very similar average scores among varieties. Like when we look at germination here, we have a lot of similar scores. It could also be well-spread mean scores, but high variation within each variety, like yield. Again, you can see this is another grower in Alberta, again, outside of Calgary, Alberta Telfer, with her kind of final selections of radicchio. Again, very beautiful, distinctive, and a great opportunity for growers. So when we look by variation by environment, there was no genetic genotype by environmental interactions. There's no case of varieties doing significantly worse or better in one environment or the other, with the caveat that our environmental variable east versus west, and this was east being the growers in Ontario and Quebec, and west being growers in Alberta and BC, is a fairly broad category and certainly does not capture environmental characteristics that determine variety performance. On the one hand, it might have been more interesting to see regional differences. On the other hand, this demonstrates that these varieties may be broadly adapted and therefore suitable candidates for regional seed production. However, although we did not see genotype by environmental interactions for varieties as a whole, there was a suggestion of genotype by environment interaction for yield in radicchio. We can see this in the TVG1 performing better in yield. In the east, I have it marked off by a little radicchio icon. So the TVG1 in the east had better yield than the TVG1 in the west. The fact that we see hints of genotype by environmental interaction, by environment interaction, but not statistically significant results, has to do with both our trial size and the way we rate our traits via SeedLinked. Unless something is fantastic in one place and horrible in another, it's hard to get enough spread in mean scores to result in statistical significance. If we use quantitative measures like actual yield in pounds, we might have a better chance of detecting this. And this is a good, indicator for us to maybe for future trials, looking at more of these quantitative measures. And as I mentioned earlier, I said we'd come back to this Pascalino variety, which did very well in the trials in 2022, but also in previous years. And I'm highlighting this because it performed well on sites across Canada, which is a really important result from the 2022 Kenobi trials, showcasing Pascalino as a variety that seems to do well across the board. And is also a strength of this approach of having on-farm sites and hub sites. It rated highly for marketability in both 2021 and 2020, had the highest yield in the west and the second highest in the east. This chart here with the is at the end of a Data collection at the end of the harvest, growers will be asked, would you like to grow this again? And the 76% in blue is growers who said, yes, I would like to grow it again. The 24% is growers who said no. So that's a pretty good amount. We had some great comments from farmers in Alberta and Ontario talking about how beautiful, how striking the colors are, and matured well and had yield potential. So it's something we're looking forward to possibly seeing more growers across Canada growing. And also, it's, as you can see, it's very beautiful, and it is a striking radicchio. So next, I'm going to talk about a little bit about our Pinovi orange carrot breeding program. In the radicchio trial results, we saw the strength of the on-farm trials and what they bring to participatory variety trials. And now we'll highlight some of the strengths that the researcher component of this collaboration brings to the table. So out of this Pinovi orange carrots program, we've created a new orange Nance storage breeding population, which was selected based on marketability, flavor, storage, shape, and carrot rust fly damage. The folks at UBC, they tasted every single root for flavor, and you can see them doing that here. The carrots on the top here are carrots that were selected that they liked. The ones in the middle are carrots that someone thought that they were a little too harsh, and the bottom ones were the ones that were not selected. They've saved 74 root seeds, making it the 5th generation in the greenhouse. And we're hoping to plant these out next year. Originally, the goal of these trials was to test the Pinovi orange and red carrot populations alongside commercial hybrid and open pollinated cultivars to see how ready they are for commercialization. However, unfortunately, we had a bit of a thrips issue in the greenhouse, which resulted in almost no germination in our red carrot population and about roughly 30% in our orange carrot population. So in 2022, we had to adjust our goal to just be about comparing commercial cultivars, open pollinated versus hybrid, to see if we can detect patterns of performance by region or identify any open pollinated varieties that were competitive on some or all farms with hybrids. So here, again, we can see this chart that we had similar to what we had at the radicchio slide. Again, the more green it is, the better result. Orange, kind of a middle result. Red, not so great of a result. And here we can see the amount of asterisks by it is how statistically significant the results were. So canopy cover, there was differences, germination, vigor, and yield. We see Bolero competing very well, followed by Navel, Touchon Deluxe, Duchelina, and unfortunately Pinovi orange at the bottom, but we're hoping, again, we get that germination issue. We're hoping that next year it'll be a bit higher. When we look at variation by environments, we're again doing the delineation environments between East and West. So the East is 13 participants in Nova Scotia, Quebec, and Ontario. And the West is the 17 participants from BC and Alberta. And we can see here that all traits except appearance were rated significantly higher on Western farms than Eastern farms. There were no cases of genotype by environment interactions in which one variety did significantly worse or better in one region than the other. And we have the same variety rankings in both the East and West. Their ranking was Bolero, Navel, Touchon Deluxe, Duchelina, and Pinovi orange. Again, the environmental variable of East and West is a very broad category. So looking maybe more into some quantitative measures could really bolster this information. When we did family selection last year for the orange carrots, we found that several families had an occasional yellow individuals. So Solveig Hansen, who was our previous Pinovi coordinator at UBC, she noticed them and called them glassy yellow. And we're curious about what would happen if we crossed some of the orange individuals from families harboring genes of yellow color. And this is what happened. Several experimental crosses using individuals from 2 specific families gave quite equal segregation ratios of orange and yellow. And they're really striking here. You can really notice the difference. And they tasted a bunch of them. They're succulent, they're juicy, they're sweet. They're just really excellent carrots. The folks at UBC saved 115 roots from 3 reciprocal crosses, seed from both parents of the cross, that were derived from 2 families. We're really curious to see how this developed. We're not sure if this genetic base is a little too narrow or not, but we know that open pollinated carrot populations harbor a lot of genetic diversity. So we might be okay. It's just an exciting development, and we'll see. The folks at UBC have named it Kenobi Fire Glow. So hopefully you'll hear more about that in the future. Another exciting collaboration with farmers and researchers is our access to research populations. On the right-hand side, we have Fantasia carrots, which were developed by the Organic Seed Alliance. They're not available yet, but they were trialed on farms in Canada through the Kenobi program. And we're really excited to see how this variety grows and eventually gets on the market. So with farmer and researcher data from the Radicchio variety and variety trials and carrot breeding program, what can we take away? When we look at genotype by environmental interactions, when it is detected, either statistically or via observation, the key is to choose how to deal with it. You can recommend that variety or focus breeding for that population if it's still in development on the region for which it does really well, or you can choose to favor broadly adapted cultivars, including open pollinated varieties like the Pascalino Radicchio that do pretty well across a wide range of organic farm sites. The latter results in a larger potential market and thus more feasible or affordable seed production, but might not maximize productivity or quality for a specific region. Regionally, but not broadly adapted cultivars can be fantastic for a specific area, as long as there's regional seed, a seed producer or provider that can profitably make and sell that seed. Another thing that we found that was really interesting in this program is that growers seem to be really interested in heterogeneous populations. One example is that renegade red pepper that I mentioned earlier. I was talking to Rebecca Ivanoff, who's part of that group, and she said that they ended up releasing the seeds early, even though the red pepper had some yellow in it and wasn't completely ready for market. And they did this because people were interested in saving and selecting seeds for their own farm and seeing what a more diverse population can do in their climate each year. And this is something that doesn't fit into conventional breeding systems, which require a lot of uniformity. We also have seen in our grain cropping side of participatory breeding, the participatory wheat and oat program. There's a farmer in Alberta who has developed their own participatory wheat and is now growing it out. They've mixed that seed with 13 other heritage wheats and is growing out that population for their own farm, for their own markets, for building resiliency and also different traits and seeing what builds over time. So it's really exciting to see that folks are interested in heterogeneous materials. So far, the 2 key takeaways from Kenobi when it comes to genotype by environment interactions is that it's important to choose how to deal with the results and then figure out what we're going to do with, and then also just that it's interesting that folks are interested in heterogeneous populations. So when working with participatory breeding, there are a few really great benefits of this farmer-researcher collaboration. First of all, farmers are engaged in learning about variety availability, open pollinated varieties, and seed diversity. There are opportunities to identify organic open pollinated varieties that can be incorporated into crop planning, even if it's not regionally produced, and opportunities to gather feedback to guide regional seed production and breeding outcomes, with the ultimate outcome being more varieties to be available for organic growers in Canada. Ultimately, other than this project, there's not really research happening on organic vegetable seed in the country, barely anything on breeding vegetables for organic farming conditions. If we, presumably as a community, want to also have local organic seed for the local organic food we're eating, this is ultimately the kind of research that needs to be supported. If you're interested in Kenobi and participating in our next phase, we will be continuing the carrot work. Again, we had that little setback with the orange carrots, but we're hoping to get another step forward with that with higher germination. And we're also going to be launching trials on salad or leafy greens. One of the limitations of the trials that I'd like to acknowledge was that there wasn't enough regionally produced open pollinated varieties being evaluated in the trial designs. And that's something we're looking to correct in this next iteration of the project. But varieties like Cornelian, red carrot breeding projects from Organic Seed Alliance are now available at High Mowing Seeds, and varieties like Touchon Deluxe are available at BC Eco Seed Co-op. And there are open pollinated varieties that have a bit more profile now. And then stimulating demand for breeding populations like Canopy Orange and Fantasia from the Organic Seed Alliance can be useful for commercialization before these varieties are released. And we're looking for feedback on, we're currently developing what our salad green and leafy green trialing or breeding program can look like this year. And we're definitely looking for feedback from growers across Canada. So after this, I will quickly throw that survey link if you have a chance to give us some feedback on what would work for your farm and for what you're looking, what would work for your farm. If you're interested in interesting genetics or any other kind of variety trials out in Canada, definitely check out Seeds of Diversity's community growouts. They have a dwarf tomato project, a beans for Canadian climates, and upright ground cherry breeding. And if in general you're looking for interesting seeds, again, Seeds of Diversity is a great place to check out. They have a list of Canadian seed companies. You can even search by vegetable and they'll give you all the different varieties in which seed companies in Canada sell them. Ecological Seed Finder is a great resource to find regionally adapted seeds in your region. And you might be able to find something interesting from the Plant Gene Resources of Canada. I know they mostly do grain crops, but I think they have a few vegetable crops. If you're not able to find what you're looking for, Seeds of Diversity and Ecological Seed Finder, that might be an interesting place to check out. We'd love to stay connected with you. If you're interested in seeds and plant breeding in the prairies, we have the Prairie Pod newsletter. It used to be a quarterly newsletter, now it's every 2 months, and it's all about seeds and plant breeding on the prairies. So definitely sign up for that. You can check out information about the Canopy program as well as other webinars. We have a podcast on our website at seedsecurity.ca. I always make sure to share the opportunities with Canopy and updates on the program with Manitoba Organic Alliance, Sask Organics, and Organic Alberta. So make sure you're on their newsletters and following them on social media. And if you have any questions for me, feel free to reach out to me on my email. I think that's all for me. Thank you so much for your time, and I'm really looking forward to hearing from you.
Thank you, Tiara. That was great. We're going to open up the floor to some questions. I see we have one in the chat. Maybe we can start there and we'll see if any more come in. You can also raise your hand and share that way as well. So the first question is, Lauren says, we also have a thrips problem along with red spider mites. We've noticed tomatoes seem to be more resilient to them, but cucumbers always die off soon after production. Any suggestions on how to manage those pests organically?
You know, sorry, I don't have an answer for that. I can definitely check with our team. What we learned was just not to have, I think we had roses in the greenhouse while we're doing our carrot seed selection. So it's just to keep them separate. But if anyone else has answers for that, definitely welcome to that.
Okay, and I do see that Deb from Sask Organics did add into the chat that there was a pest control and organic vegetable farm session during the last mini conference that is going to be shared. The link will be shared with everyone. So that will also help answer that question. But I don't know, are there any more questions from our participants here today?
Hi, Tiara, it's Andy. I just wanted to say thank you very much for the presentation. It's such an exciting project and proud to have it part of the Organic Science Cluster program. What is the, like, if you're thinking about the impact of the participatory plant breeding, we're trying to measure its success and how it actually has impact. And what do you think is the most valuable thing that farmers get from engaging in this program?
That's a really good question. I think a lot of it has to do with the either like access to different varieties. What we do in this program is we also pay farmers to be a part of it, so that because they're doing a lot of work for us in these experiments. And so access to different varieties in these community collaborations. We try to have farm clubs online and events in person where farmers can learn from one another. Probably that farmer to farmer learning and farmers being able to gain some more tools and skills in their variety trials that they can take on to different aspects of their own farm.
Yeah, I've definitely seen some of that at some of the field days and whatnot, where the farmers are learning new skills with observing plants and deciding what might be preferable characteristics. And it's a really interesting process to go through. If anybody ever has a chance, please do it.
We do actually have some more comments coming in here. So the next one was, when do you figure this season's program will be set up regarding Canovi?
Yeah, I think in March, we should have a better idea of what we are going to be doing. We're definitely doing the carrots. There's like a good chance in the prairies we might do radicchio and rutabaga again, but maybe on a smaller scale. And yeah, maybe sometime in March we'll have the salad and leafy greens project figured out, and then we'll send out an email in the Prairie pod, and we'll also send an email to all the folks who previously participated, and we'll definitely send it out to MOA, Sask-Organics, and Organic Alberta to send out. Yeah, and we'll try to have, our aim is always to have seeds by mid-April, but I know there's a few folks who've grown with us before that sometimes that's been a challenge, but we're really pushing to have seeds in a timely manner.
Great, thank you. The next one here is, do you carry out any seed treatment fertilizing on seeds prior to planting?
I don't believe we do. We just, we don't do any seed treatments on them. We leave it up to the farmers for how they normally grow these crops to do what they would normally do.
Okay, perfect. And there's one comment here from John saying, I participated this year. I was challenged to grow something I would not have considered before. I also learned so much with other farmers. So that's great feedback.
Thanks, John. That's great to hear. Yeah, John was part of our farm club we just had, and he was really helpful to hear his experiences with other growers in Quebec, but also in different parts of Alberta. Thanks, John.
Awesome. Well, I don't know if we have any more questions. I'm not seeing anything come in. I don't know if Deb, you want to join here as we transition to our next speaker.
Great. Thank you very much, Tiara, for your presentation with us here today. It's really interesting to learn about those variety trials, and it'd be great to get some participating farms in Saskatchewan maybe this year. If anybody's interested, that's great. So yeah, with that, I guess we'll move on to our next speaker, who is here today to discuss calculating costs of production on small-scale vegetable farms with their resources enterprise budgets. Wallapak Palasab is here today. Wallapak is a senior research associate at the Institute for Sustainable Food Systems, Kwantlen Polytechnic University. Originally from Thailand, she moved to Canada and made Vancouver her new home in 2011. Her research interests are on economics of local food systems, farm direct marketing, community food security, and consumer behaviors. And she also loves extension and outreach work that allows her to work with producers and consumers of local farm products. So with that, I will welcome Wallapak and stop sharing my screen and turn it over to you.
Thank you, Deb. Can you hear me okay?
We can, thank you.
Okay, I will share my screen. Okay, let me see. Okay, thank you so much for having me today. And just definitely introduce, my name is Walla Pak, and from the Institute for Sustainable Food Systems, and I'm here from Vancouver, and which is located on the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. And the Kwantlen University also was gifted its names from the Kwantlen Nation also. And in the cause of reconciliation, we recognize that our commitment of the university to address and reduce the ongoing systematic colonialism and oppression and racism that Indigenous peoples continue to experience, especially in the field of agriculture as well, that we have so many legacy. So within the Institute, we work a lot with various stakeholders, such as local governments, community organizations, and farmers. And we focus on advancing local regional food systems through regenerative organic agriculture, community development, and reconciliation. And one of the things that we do is providing information to farmers. And that's what I'm here today to talk about our enterprise budget tool that we produced. So before we get there, I start with some fun facts about BC a little bit. Our cultivated area is about 3% of total land area. And you also probably know that we are the largest producer of blueberries and cherries. And just this past census, we surpass now everyone in the area in growing mushroom as well. But do you know also that we have the highest percentage of farms operating under 10 acres and the highest percentage of female farm operator, and the third highest percentage of farm reporting selling organic products. I know I'm a little bit of a geek this way, to quite a lot of statistics to show. Okay, let's get to business. So an enterprise budget provides detailed information of costs and returns of an operation of a particular product for a specific period of time. It shows you what expenses you have and how much money you're going to make. It's different than the whole farm budget because the enterprise budget separates one product from the rest. And if you have a diversified working farm and growing maybe say 20 different crops, your whole farm budget would cover all products together. However, an enterprise budget gives you cost and return for a particular vegetable separately so that you can compare them to each other. And our enterprise budget tool is hosted on our website, and the uniqueness of our budgets is that they are designed specifically for small scale farming operation. So we have 26 budgets for crops and livestock commonly present in the southwest region of British Columbia. So these are the list of them. And we started this work in 2014 and received information from our representative small-scale farmers in our region, and the budget were published in 2015. So it's been over 8 years, and I'm sure these numbers that we have in the budgets are outdated. However, the nice thing about the budget is that the templates themselves are designed so that they can still be a useful tool. So let's have a look of how these budgets work. So when you go to the website, you see the list of the products, and then there'll be two columns on the right. So, and you see that the downloadable. If you click on the name, for example, the two types of file, PDF file and Excel file. The PDF file are static, so you cannot change any result presented on there. But then the PDF, the Excel file the templates that I mentioned. So they're dynamic templates, and you can change things and you can download them and use for yourself. And so in the next few minutes here that we have, I'll go through how to use them. So once just for the purpose of illustration, we'll pick bell pepper enterprise budgets as an example. Once you download a file and open it up, so it's Excel file. Once you download it, open it up, you will notice at the bottom, so these are can you see my cursor?
Yes, we can.
Okay, so at the bottom I highlighted in the red box here. So these are the different sheets that we have. And you might feel a little bit overwhelmed. Don't worry about it. They're actually pretty straightforward. You yourself know all this information already because you work, with these numbers all the time. It's just that our team put them together and organize them in an Excel format for you. So this tells you the number of sheets that we have, several sheets, and the sheets are organized according to the types of costs and revenue and the summary file. So for example, we have here the fixed costs and overhead charges. VC stands for variable costs. We have 3 sheets for variable costs: material costs, operational activity mostly deals with labor and fuel charges, and marketing fees, variable costs, and then revenue, and then analysis. I'll go through them one by one to give you more information. So first, let's have a look at the fixed cost sheet here. First, fixed costs refer to costs of production that do not really change with the level of production. The examples are farm machinery, equipment, land rent, internet fee. You have all these costs anyway, whether or not you grow the bell pepper this year. So one thing to note about our template is the colors of the cell. Yellow means changeable and green means leave them alone. So in the yellow cells, they are the ones that you can enter your own information. And once that's done, the green cell will repopulate themselves. So you don't need to do anything with them. So here, remain on these fixed costs and overhead charges again. So on this page, if you notice at the top, there's a top box here. This is where you specify the area of production. And when we talk to small scale farmers, they all diversify mixed crop farm. They don't just grow one thing and then that's the whole farm. No, they have the farm and then they grow between 20, 30, some even nearly 40 types of crops on their farm to go to markets. So therefore, in this example, we have this farm operating just under 4 acres, and bell peppers practices are similar to other long season crops. So then we say, we have 4 acres here and then 1/4 of an acre for long season crop and 0.06 acre in bell pepper production. And that's about 2,600 square feet. And we picked the standard for 100 feet by 400 feet bed size. And that translates to about 6.5 beds, but then 6.5 beds doesn't make sense. So we round it up to say, let's say that this is 7 beds. And again, these yellow cells, you can input your information and then the green cell will repopulate themselves. And interest rates are, this is useful for calculating depreciation and loan payment. And so we put in there how many percent, and then the growing season in Southwest BC, our season, the whole long season is about 8 months. So we put it in there. Some other places could be shorter, longer. So this is where you enter all those information. And here in other table, remain the same one, fixed costs and overhead charges, the table below, you can enter the types of fixed costs that you have on your farm, the price, and also the estimated useful life in the yellow cell. because again, because all this machinery and other things, all these costs are shared for all crops grown on the farm, right? So what we do is that in the last cell here, we calculate and separate just the cost devoted to bell pepper, so that, you know, instead of saying that, oh, we have 20,000 tractor, that's not for the bell pepper them itself, you know, it's shared for everyone. And so in this particular case, we calculated down that, oh, for this year, the cost of tractor use for bell pepper only is about $26. That's just, you know, that's just the way we calculated it out for you. The thing that you need to do is changing things on the yellow cell. And so the next section is the variable cost. We have 3 variable cost sheets, and variable cost refers to the cost that vary with the level of production. If you produce a little bit more bell pepper, this cost is going to increase as well. So there are different types of variable costs. That's why we devoted 3 sheets for it, just to separate them out clearly. So the first one is material. Again, the operational activities refer to labor costs, labor time and fuel charges and marketing fee. So in this, for an example, just use this particular one that we have. These are material costs. So the nice thing is, in every sheet, on your farm, you might use different things than the things that we put in here. So what it is that you can insert a new row. You can click insert a new row and then add your own, type in your own items that you use. And yellow cell, you type in the quantity and the price, and then the green cell repopulate the cost of that. So same idea. So put in whatever things you use, you know, the price and the unit that you have, and then the green cell will repopulate and calculate the cost for you. And next is the revenue. So it refers to the total earnings or the gross receipts from selling products, in this case, selling bell peppers at a particular price. So in this example, we sell our pepper at $4.50 a pound, and within the 0.6 acre here, we have approximately 1,500 pounds. And then this is the total revenue or the gross receipt that we're gonna get. Now that is the fun part. So we're gonna go back to the enterprise budget page right here in the left of the screen. So this information summarizes all the information that we have, that we input, because we already have inputted the fixed cost, variable cost, and also the revenue. And now we're going to summarize the information in the enterprise budget to see, you know, whether you're going to be in the red or whether you're going to make a little bit of profits. So if you scroll down to the bottom of the page, around 165 row, you will see the summarized table, a table that summarizes the information. In this particular example, we say that according to the cost and revenue that we have, you approximately are going to get about $570 per bed, per 100 bed. And if you grow 0.06 acre, that comes to about $4,000 in profit. And this is the approximate numbers that you're going to get when things go as planned. As you said your yields 1,500 pounds, and then you're going to sell it at $4.50 a pound. But what happened when things do not go as you plan? So that's what the analysis sheet is going to do for you. So the analysis sheet right here in the far left, it has 2 tables. So one, the top one shows the the analysis tables here show how sensitive your bell pepper operation is in relation to the changes in cost, price, and yield. So the top table shows how your net returns might change if the price and yield change. And the bottom table shows how much you have to produce to break even. And again, the analysis in this sheet are automatically populated. You don't need to calculate anything as long as you enter all the information in the red, in the yellow cell, in the yellow pages there, on the cost and revenue pages. The green cells on this sheet will repopulate itself. So, but remember, things are adjustable because you might not like our example that we show here, 10%, 20% increase, 30% increase. You might want to say 5%, 10%, 15%. You can do that. So you can change things in the yellow cell. And then we will calculate all these sensitivity analysis results for you. So in this example, so given that we expect that we're going to sell it for 50 pounds and our yield is going to be 1,500 pounds per 0.06 acre, and this particular cell here, this is what we expected in the normal situation there, right? And that tells you you're going to make about $40,000 from the production of bell pepper. However, in this cell, you know, if the price decreased by 20% to 360, for example, and then your yield is actually reduced by 10% to about 1,300 pounds. Now it's that this cell said, well, now your profit's going to reduce and you're going to make about not $2,000. So, and another example here in the lower table, here we said that, you know, if things go as planned, you need to produce about 600 pounds of bell pepper to break even. If you produce more, you're gonna make a little bit of, you're gonna start making profits, and if you're gonna make, if you make less, you're gonna be in the red. And this cell, this is where things, when things don't go as planned, if the price increase though 20%, but the yield, the total cost also decreased about 20%, then your break-even point is you have to produce about 400 pounds to break even. Yeah, so I think we have a little bit of time, so I would like to actually go to the actual template and see how it changes. So here's the Excel file that I mentioned. And since we were on the analysis sheet, let me just show you. Here again, say for example, you know, let's say I'm going to change this cell, this column here. So I'll say that if I want the price to do sensitivity analysis to be 5% here, and then you will see everything here will change later like that, right? And then 10, and then 15. So this is an example. Now let's go back here in the fixed cost sheet where we set the stage of how big your operation are. Here. So for example, you know, you might have 5 acres, and you might say, and if you have long season, it's 0.5 instead, and this one could be 0.01. Now that area is changed in square feet, and now your bed is approximately 11 bed. And now just gonna show you, sorry, I'm gonna show you a little bit, one more example with the interest rate, for example. Interest rate, like I said, it ties to depreciation and also the interest expense on loan payment. If I change the interest rate, the cell here is going to change. For example, if I change to let's say 6%. Now this thing already changed from 500 to 800, for example. And here's, let's change something here. For example, the tractor. Yesterday, I was just looking at the New Holland tractor. Now 8 years later, it's 20,000, 30,000. Let's say change to 30,000. So that changed, depreciation change as well, and then the things on here change. So this is how it works. You know, you can input your own information and then adjust the number to be current, and then something new that you use, and then you can enter however dollar it is, and then you started to populate it 5 years, there, then you get this number. So it might look overwhelmed a little bit, but once you play around with it, it's actually not too bad. So let's go back to the last few slides that I have. This is just to summarize for you a little bit what enterprise budgets is used for. So once you have all these budgets for each product, then you can compare them, right? And then you can see, oh, this past year, look what happened this past year. I grow bell pepper, bok choy, all the list here, this much, this area, this selling at this particular price and the yield that I have. And then at the end of the year, then you can compare, oh, which one actually makes money, which one has a lot of expenses that was put in there. So these are some of the things that one benefits of using the enterprise budget to help you a little bit to see, help you plan for next year, what you want to do next year, how you can adjust the expenses, and that's it for now. And if you want to check out our YouTube channel, we have other resources to help small scale farmers as well. And if you have any questions, feel free to get in touch. Thank you.
Thank you so much, Willapak. That was excellent. Those are really fantastic resources, and it's great that they're just so customizable and kind of timeless. Even though they were created in 2015, you can just still edit them so much to today's figures and to your own operation. And I particularly like the sensitivity analysis. Also, I think it's just a really great way to be able to see sort of your best and worst case scenarios. And yeah, so thank you very much for sharing them with our group. Does the Kwantlen University plan to continue their work on developing more different types? I saw you had a great selection already.
Yeah, I mean, it's on one of the list of things that we would love to do. However, it's all about, the funding that we have to get a person to do. My colleague who no longer is with us, actually, he spent nearly 2 years working on this, getting information together and building this amazing templates. And the funding is a little bit hard to come by, but that will be on the list of things that we want to do. If you people think that it's useful, send us an email and say, hey, do more, and then we can send the testimony to funders and say, see, people have been using it.
Absolutely. Yeah, no, that's great. And I will share the links to the tools themselves, and then some of those other links just at the end there where you shared with the YouTube videos and things like that with attendees after.
Yeah, and I also want to say that a couple of people's email us actually, and they found mistake on the file, and then this is very useful to us. So then we got to go back and then revise it. So I think we had some miscalculation on the yield per acre per bed, and then the budget for cucumber was like $5,000 per bed, and then one farmer emailed and said that doesn't sound right. And then like, you're right, we just made mistakes. So if people help using it, and then we can make sure that all the informations are good.
Yeah, that's great. That's good feedback. I'm not seeing any questions yet. I'm just seeing lots of comments saying that these are excellent tools and they're just really grateful for you sharing them. One question did just come up. How easy is it to change the bed size?
Right now, unfortunately, we just do it at let me see, because we put it at the standard 100 by 4, and I think some of our farmers did 70 by 4 as well. Let me see. I think you can change the bed size, but then you have to calculate yourself in terms of square feet. So let me just go back one more time. Hang on just a tiny second. I think again, the yellow cell, oops, sorry. Yeah, share. here, right? Here's the yellow cell. So these are the number of acres and that's square feet. And if you want to change it to, if your bed size is actually 70, then it's going to be 70 times 4 is 280. And you're going to say 280. See? And that number of bed is changed. So, sorry. So this thing, it's green, you can't change. But if you want to change the square feet themselves, you have to just make a note that now my bed size is 70 by 4, right? And that, oops, sorry, not my net size, my bed size, 70 by 4, and then the total square feet, 70 by 4 per bed is 280. So when you change that, then it moves to 16 bed. And if it was 100 by 4, then it's 400, it's only 11 beds. So you can change it, yeah. You can change the bed size.
Okay.
If you do actually download and use them though, I can tell you a trick how to change the green cell, but we just don't recommend it because if you make mistake, then it's just gonna be, things gonna get messed up.
Right, okay. One question did come in here. Is the program standalone or can a user adjust the cropping information? And I'm not sure maybe if they mean adjust the type of.
Yeah, so this gets a little bit very detailed. I'm glad you asked that because it takes a little bit more explaining than I shared. For example, here in the cropping detail, it's under marketing fee 1 because this is where we list out the things that, what are the things that we grow. In this example, we have the 20 different crops here. And then that's how we say that how the costs are shared. And bell pepper cost, is this much of the tractor uses for all year. So these are examples. So in this example, there were 20 different crops. And this is where you're gonna put in all your crop information on your farms. Yeah.
Okay, great. All right. Yes, and then you already addressed the bed size can be updated. Somebody just commented that the standard bed size seems to be about 30 inches. Great. Well, unless anybody has any other questions, I'll just thank you again, Wallapak, for being with us here today and for sharing these excellent resources with the group. We really appreciate it.
Yeah, thank you so much for having me. Bye.
Hi. And so now I'm just going to share my screen again, and I'm going to pass it back over to Macy to introduce our next speaker.
Thank you. So next on the program is Dr. Sean Smuckler. He's here today to talk about nutrient and soil management on organic vegetable farms. So I'll just read his bio here. Dr. Sean Smuckler is an associate professor, chair of agriculture and environment, and director of the Center for Sustainable Food Systems in the Faculty of Land and Food Systems at the University of British Columbia. He also currently leads the Sustainable Agricultural Landscapes Laboratory. His research primarily focuses on developing ways to help farmers adapt to climate change and improve the sustainability of their farming practices, specifically as they relate to the soil. Sean received a PhD in ecology from the University of California, Davis, where he also did his undergraduate studies. He holds a Master of Science in Forest Soils from the University of Washington, Seattle. Thank you, Sean, and I will pass it over to you.
Great, thanks very much, Macy. Can you hear me okay?
Yeah, you're good.
Perfect, great. Yeah, good morning, everybody. Very nice to see you all. I'm just gonna start sharing my screen here. All right. Yeah, so to start with, I would like to just acknowledge that I'm speaking to you from UBC's campus here in British Columbia, which is situated on the traditional ancestral and unceded territory of the Musqueam people. I would also like to acknowledge the many collaborators that I've worked with to put together the information that I'm about to present, and the many farmers that we work with. So my work is largely on commercial farms around the southern part of the province. And of course, this work would not have been made possible without the funding from organizations like MyTax and the Organic Science Cluster with the Agriculture and Agri-Food Canada, the Ministry of Agriculture, and the Climate Action Initiative. So for the next 50 minutes or so, I'm going to talk about regenerative agriculture in the context of organic vegetable production, and contextualize it in terms of the principles, practices, and outcomes. And then bring it here to agriculture in British Columbia, talk about some of the ongoing efforts on regenerative agriculture. And then I'm going to jump into our research. So I'm going to share with you results from a series of studies that we've been doing since 2015, and share with you the outcomes of that research in the context of regenerative agriculture. And then I hope to leave at least 10 minutes for questions at the end. So regenerative agriculture has become a catchphrase in many circles in agriculture. And if you asked everybody in this audience here what their definition of regenerative agriculture is, we probably get many different definitions. And I think it's going to be one of these things where over time we will hone the definition and come to some agreement. But I think the definition that I like at this point is it's an approach to farming that uses soil conservation as an entry point to regenerate and contribute to multiple ecosystem services. And I like this definition because, one, it's focused on the soil, which I think we really need to keep the discussion about regenerative focused on. And it is making sure that regenerative is contributing to not just production goals, but to many different goals of the farm and the landscape surrounding the farm, recognizing that as farmers, we're responsible for the stewardship of our global lands. So many people focus on the principles of regenerative agriculture, and I think these principles are, again, there are many different views on what principles are for regenerative agriculture, but I think these are some that I think many can come to an agreement on. So maintaining a living root system in the farm soil, minimizing soil disturbance, maximizing crop diversity, making sure that the soil is covered throughout the year, and then integrating livestock is one that many attribute regenerative principles to. And then there's a bunch of practices that are associated with regenerative agriculture. So within that set of principles, you can be doing conservation tillage or cover cropping, using complex rotations, managing residues to make sure that you're mulching the soil to armor it. And then there are practices related to nutrients, integrating nutrient and pest management, and adding organic amendments. And I highlighted integrating nutrients and adding organic amendments because that's what I'm going to be focusing on here. And many of the organic producers that I work with are challenged by these two components. And I'm going to explain why these practices are challenging for our farmers here in the province. And then finally, we of agriculture from the context of the outcomes. And this, I think, is really important because while we have a lot of evidence that these practices are functioning to achieve the outcomes that I'm listing here, the outcomes can be highly variable depending on the way the practices are being implemented, given the particular context of the farming system, the soil, the climate, the availability of nutrients, for example. And that's something that I'm going to focus on in a minute. So when we talk about outcomes for regenerative agriculture, typically one of the main outcomes that we're looking for is the improvement of soil health, or the regeneration of soil health. We also are looking for a reduction in the impact on the environment. We're hoping that regenerative agricultural practices result in a net benefit to the ecosystem. At the same time, we're looking to improve the resilience of the farm as well as the farm's profitability. And then many are looking to regenerative agriculture to achieve some climate benefits. So being able to sequester carbon to mitigate climate breakdown. And most of these outcomes are predicated on the idea that regenerative agriculture improves soil organic matter. And many of these outcomes can be directly related to the outcomes that can be achieved through organic matter improvement. So let's talk about British Columbia. So I'm part of a advisory group that's made up of representatives from agriculture, from the agricultural industry, from academia, from government, and we have been tasked to provide advice to the Minister of Agriculture on how to implement a shift to regenerative agriculture across the province, supported by agritech. And what I'm showing you here is the culmination of months of committee work to develop this framework to provide guidance on how to implement regenerative agriculture at a wide scale across the province, based on an agreed upon set of vision, mission, values, and goals. I'm not going to go into this in depth, but this is just to contextualize the work that we're doing in British Columbia, and to recognize that our Ministry of Agriculture is putting this front and center as a solution to many of the challenges that our producers are facing today. And so the vision is British Columbia's food systems follow the principles of sustainable agriculture to continuously improve our lands, waters, and ecosystems. So British Columbia, the far west of the province, is largely mountainous. Most of the work that I'm going to talk about will be here in the southern part of the province. Just a quick introduction to what BC agriculture is like. We've got more than 2 million hectares in production, which is less than 3% of the total land base. So much of the province is mountainous and forested. We have incredible diversity in the province. So we have over 200 agricultural products on nearly 16,000 farms. We interestingly have the highest market share of organic fresh vegetables in the country, with 7.4% of our province's total sales being organic. We are also, I think, the poster child at this point for climate change. So over the last few years, BC has just been rocked by one climate-related event after the other, from extreme weather that has precipitated in forest fires across, to extreme precipitation that has flooded much of the province. We've had a heat dome that had important impacts on many of our producers. And it is clear that we are now squarely in a climate crisis. We are seeing the breakdown of the historical patterns of climate that our producers have learned to manage for. And we need to figure out quickly how to adapt. And this is where the province is really looking to regenerative agriculture, not only to help producers manage their system more effectively, but to also mitigate the emissions that are coming from our agricultural system. So when I arrived in British Columbia in 2012, this study had been just underway. And this contextualizes what I'm going to talk about in terms of nutrient management. So the British Columbia Ministry of Agriculture led this study. They surveyed 177 agricultural fields after harvest for soil nutrients. This was a follow-up to a 2005 study that they did. This was led by Claire Sullivan and David Poon. And they contextualized the analysis within the provincial recommendations for post-harvest nitrate down to 60 centimeters, soil test phosphorus down to 15 centimeters, and soil test potassium down to 15 centimeters. And in the context of low, medium, and high, very high ratings that the province had been developing over decades. So this study took place in the far southwestern corner of the province in the Fraser Valley, one of the most intensive production regions in the country. And the results were really interesting. So one of the reasons this is considered one of the most intensive production areas in the country is because of the density of animal production. So we have a high density of dairy operations and poultry operations producing a large quantity of manure. So when we look at the fields across this region, we're seeing a large percentage of the fields with very high post-harvest nitrate, high medium soil test potassium, but most importantly, we're seeing fields with very high post-harvest soil test phosphorus. And when we looked specifically at the vegetable production, the average was 187 milligrams per kilogram, down to 15 centimeters. That was 100% of the 30 farms sampled. So we don't know how many of those were organic vegetable farms or conventional, but it was clear that we have a phosphorus issue in the Fraser Valley. And so this led into some of the work that we started. And what we were interested in is figuring out how to better balance nutrient applications with crop demand. So typically what's happening in our systems is that we're targeting the nitrogen demand of our crops so that we can maximize yields. And in that process, by putting on the nitrogen that the crop needs, we are oversupplying the phosphorus that's going into our soil. And one of the key issues with that is that oversupply of phosphorus begins to build up the phosphorus pool. So by targeting nitrogen, we're putting on too much phosphorus. If we instead targeted phosphorus, we are limiting crop productivity by the nitrogen that we're applying. So what we need to do is figure out how to get that extra boost of nitrogen into the system so that we can better match the nitrogen to phosphorus ratio, which is in our manure heavy compost, 3 to 1, Whereas many of the crops that we're seeing grown across the region have nitrogen to phosphorus ratios from 5 to 7. And I'll show you some of our data in a minute that actually shows that our crop N to P ratios are even higher than that for some of our vegetables. So when we're thinking about crop fertilization, we need to be able to target the nitrogen release from our various sources of nutrients with the crop demand. So in green, we've got the crop demand over the course of the season, and then we have harvest. And what we typically see is when we use, particularly in organic systems, nutrients that are based on compost or manures or organic certified fertilizers and cover crops, that we see that the timing of the nutrient release is not necessarily in line with the demand of the crop. So over the course of the season, we've got the nitrogen release, but then we also have the microbially mediated release of phosphorus. And when we're putting on that phosphorus, we can be releasing too much early on in the season, or not timing it right when the crop is needing it. And this becomes even more complicated in many of our vegetable production systems because they're mixed. So we've got not just one crop to deal with in terms of matching the demand, but we've got multiple crops. And so if we're reliant on our cover crops or compost alone to provide nutrients, we're often applying these nutrients across the field. And therefore, we're giving a single application to the entire field. What this ends up doing is some parts of the field are over applied, some parts are under applied. And as a result, we can end up with nitrous oxide emissions. So the nitrous oxide is a powerful greenhouse gas that I'll talk about more in a few minutes. We can end up with reduced yields for one or more of the crops in that mixed system. We can end up with some of the nutrients being lost through leaching into our groundwater or out to waterways. And then importantly, we can end up with phosphorus buildup. And for regions of our province that are proximal to important aquatic habitats, this phosphorus can be a really important environmental risk to consider. So when we started this research that I'm about to present, our principal question was, what are the regenerative outcomes of organic vegetable nutrient management practices? And importantly, how can we make them more regenerative? Or can we make them more regenerative, and how do we do that? So the research was started by a postdoctoral fellow, Gabriel Maltius Laundry, in 2015. Gabriel's now a faculty member at the University of Florida. He addressed this question by starting a fairly simple experiment at our farm at the UBC campus. So we have a 24 hectare, 60 acre farm of mixed vegetables, where we began a nutrient management trial with four treatments. So the first treatment was applying a low level of compost. So this would be municipal compost that would match the phosphorus crop removal. And so with this treatment, we expect that we won't be building up phosphorus over time, but we may be under applying nitrogen. In our high compost treatment, we'd be matching the crop N demand, and likely because of that N to P ratio, building up a phosphorus pool in the soil, excuse me. And then we compared this to a manure application, a poultry manure with much higher readily available nutrients matching the crop demand. And finally, a combination of a low compost that would be matching the phosphorus demand, but then we boost the nitrogen to match the end demand with a readily available nitrogen sourced from an organic certified fertilizer, blood meal in this case. So we established research plots at the UBC farm. These are replicated and highly controlled plots. We work closely with the farm manager to ensure we're meeting both production and research objectives. So I'm going to go through our application rates, and I know I'm going to throw out a bunch of numbers at you. I'll try to go through this slowly and carefully. I think the principal outcome that I'd like you to understand is the ratios that we're putting on are not matching the demands. So in the low compost situation, we have the availability of inputs, and then for the target crop, we calculated that we need 150 units of nitrogen and 25 units of phosphorus. And you can see in the low compost, we've got the 25 units input here, but the N availability is definitely not going to meet the nitrogen demand. So when we look at the balance of these, we end up where in the low compost, we are short 130 units of nitrogen. In the high compost, we're putting on an extra 135 units of phosphorus. When the manure situation, we're putting on 105 units. And in the low compost plus N, we're basically balancing out the two nutrients. So that's what we had planned to put on. And what we do is we take samples of the manure and compost a few weeks before application. We calculate the application rates from those analysis. We use previous yield data that we collected at the farm and estimated the crop removal. And in the end, our calculations were a bit off. So you can see that the actual applications, when we do the analysis after the season, we can see that even with the most careful analysis that we're still somewhat variable. And that's important to understand, so that, you know, even in the best case scenario, you're not going to be able to match the crop nutrient removal precisely. And this actually doesn't indicate what's available over the season, just the balance in the end. So what Gabriel found was, I think, largely what we expected. So we looked at two crops. So one was cauliflower and one was beet. In this situation, we're showing how much nitrogen is actually got put on, and at the bottom of these 4 bars. And the letters here are indicating significant differences in the yields for cauliflower and beets. And these yields are relativized, so we can put cauliflower and beet in the same graph. But what we see is the manure had the highest yields, as did the low compost plus N, followed by high compost and finally the low compost, which was almost half, well, less than half of the yields for the cauliflower of the manure applications. The beet, the low nitrogen to phosphorus ratio crop, was less dramatic, much closer relationship between the 4 treatments. And what this is telling us is that in these mixed vegetable production systems, if we're targeting one crop, sorry, I'm going to go back for a second. If we're targeting one crop, we could have really different outcomes based on which crop that we're actually targeting, whether it's the high N to P or the low N to P. And then we looked at the nutrient dynamics. In this graph, we're showing the four different amendment approaches with plant available nitrogen, so the total of ammonium and nitrate. And what I want you to recognize here is that we've got a lot of these stars are indicating significant differences across the 2 seasons. So this is production season 1, this is the off season, and then production season 2. And what you can see is the availability of plant available nitrogen is really high in the manure, and then way lower in the low compost. And what we don't quite understand yet is how this timing lines up, other than that we saw very clear outcomes in the yields. And then when we looked at the phosphorus availability between the first year and the second year, alarmingly, we see that in just 2 seasons of production, we see a large jump in the phosphorus pool in that manure application, whereas in the other applications we didn't see a substantial increase. What we need to better understand is how this changes over repeated applications. It's still an increase, so you can see the 0 here and the increase for all the treatments here, and no major significant difference. So what that did was led us to another set of experiments. So this was supported by the Organic Science Cluster 3. We took those same treatments, adapted them a bit, and then applied them to a second farm on a very different soil type out on Vancouver Island. Same treatments as UBC farms, same treatments as the UBC farm, and then we took a subset of those treatments. So we instituted a control for the second experiment, and the control we didn't apply at 19 farms across the province, but we did do the high compost and the low compost plus N. And this was led by a postdoctoral fellow, Kira Borden, and a master's student, Amy Norgard. So we had farms in 3 regions across the southern corner of the province. So each of these regions represents a very different climatic regime and a different set of soils that we established the treatments on. So we had Vancouver Island with a milder climate than our Fraser Valley farms, and certainly differences in the available phosphorus in the soil. And then we had farms up in Pemberton Valley where we have significant snowfall during the winter. So both the Fraser Valley and the Vancouver Island regions are fairly snow-free during the winter, enabling the potential for establishing cover crops, whereas in the Pemberton Valley, early snowfall generally prevents that. So we can see that the farms across these 3 regions all pretty much struggled with getting cover crops established, except for the farms on Vancouver Island. So 0 of the 5 farms in Pemberton Valley, 2 of the 6 farms in the Fraser Valley, and then 5 of the 8 farms on Vancouver Island. So what this is telling us is that these farms are largely reliant on off-farm inputs, that we're not able to grow our nitrogen on site. And when we sampled the compost that each of these farms were using, we interestingly found that the average N to P ratio was 3.1. Whereas the crop demand was as high as 4. So these farms are growing a variety of crops, Some of them that we calculated crop removal rates for were potato, carrot, beet, and brassicas. So you can see that the nitrogen to phosphorus ratio of the manure or the compost that are available in Vancouver Island, the Lower Fraser Valley, and Pemberton Valley do not match at all the N to P ratios of the crops being grown. And then when we look at the soil phosphorus, the baseline at the beginning of the study on these farms across these 3 regions, we can see that there's the soil phosphorus varies enormously by region. So in the Fraser Valley, where I had mentioned that there's a high density of animal production, these farms are at the baseline. We're starting many of them in the very high category and all of them in the high. Whereas the Vancouver Island and the Pemberton Valley, where manure-based compost are challenging to acquire, we see that the phosphorus at the baseline was below the high level in most cases, but in some, it was getting up into the high. So yeah, and just to mention that's a combination likely of the inherent soil properties, but also the availability of compost that is manure based in each of those regions. So in our analysis, we looked at crop yield across these farms, and we relativized the yield so that we could compare carrots and potatoes in the same analysis. In this case, we're showing the crop yields for specifically the Fraser Valley, but this is the pattern that we saw across the 3 regions, where in 2018 the Fraser Valley yields were highly variable, and there were no significant differences between our high compost, our low compost, and our typical treatment. So the typical is basically what the farmers are doing without us. So whatever they had been doing, they just continued doing. So across the regions, no significant difference in yields, except for the Fraser Valley in 2019, where both of our high compost and low compost plus N did better than the typical. So basically, our treatments were doing better than what the current business as usual approach was for the farms in that region. And again, we didn't see that pattern in the other regions. What we did see, however, was that there were significant differences in postseason available phosphorus over the course of the 2-year study. And actually, I should have walked you through what these graphs, if you're not familiar with box plots. So the black dot here is the average for the observations across the 19 farms over the 2 years. These are box and whisker plots. So this black line is the median, and then we're showing the variance with these whiskers. So what this is indicating is, while we've got a mean here, the variance across the farms within these treatments are pretty variable. But what we do see is that the high compost had higher available P than the low compost plus N, which is what we expected. We were hoping that our low compost plus N treatment would result in lower phosphorus buildup. And then when we see the typical, it's much more variable. So some farms are putting on higher rates of phosphorus than others. And you can see in some cases higher than the high compost. And then, there's no cases where it's lower, but overall, no significant difference from our high compost application. So in the end, it's largely about for many of the farmers, it's about the cost of the inputs, and the cost of the inputs for each of these regions is determined almost entirely based on the distance to where the compost can be sourced. So we expected that using an organic certified fertilizer, in this case, in this study, I should have mentioned that this was feather meal, not blood meal. In this case, we thought that the blood meal or feather meal would be a substantial expense. But what we see here in the Fraser Valley, there wasn't a significant difference between the compost, the high compost, and the low compost plus feather meal. No significant difference there. But what we did see is that producers are applying rates that are significantly cheaper than the alternatives that we had put on. The story is quite different in Pemberton Valley and Vancouver Island, where sourcing compost is challenging. It requires a fair amount of trucking to get the compost on farm. And so we don't actually see a significant difference on the Pemberton Valley farm sites. On the Vancouver Island farms, again, no significant difference, but you can see that the costs are substantially higher than those of the Fraser Valley or the Pemberton Valley. And look at some of these outlier farms. The farm cost, depending on where the location on Vancouver Island was relative to the compost facility, can be enormous. So that's something that is really important to consider, that basically the financial benefits of these alternatives really depends on the proximity to the availability of animals and compost. So this led us into a third series of experiments. Again, we continued our experiments at UBC Farm with a similar set of amendments. This was supported by the Farm Adaptation and Innovator Program. We continued our experiments at Greenfire Farm. The difference was, in this case, we were adding a layer of cover treatment over the winter. So we were using either cover crops or plastic silage tarps to keep the treatments covered, or the plots covered. And then we took a subset of those experimental treatments and again deployed them on 12 commercial farms at different locations in different regions across the province. And our intention was to continue looking at the amendment combinations along with the cover on these commercial farms. But because of COVID, we just couldn't execute the management required. So this part of the project was largely led by my project manager, Carson Lee, and a master's student, Rolani Kessler. So what this meant was that at the UBC farm, we had a continuous experiment running since 2015, where while the treatments varied a bit, the consistency of the treatments was basically this, where we had high compost application, where we had 37 tons on average per hectare being applied, a low compost application where we had 24 tons of compost being applied, and then a low compost application plus nitrogen where we had 27 tons applied. And then a control where we were applying a very low amount, and in fact, just one application over the course of the experiment since 2015. And over the applications across those years, we maintained an average of a nitrogen to phosphorus ratio of 3. So what I'm going to talk about here are the outcomes related to carbon sequestration. So part of what people hope regenerative agriculture will do for farms is to sequester atmospheric carbon dioxide into the soil, thereby building up soil organic matter and all of the benefits for the farming system, while at the same time keeping that carbon locked out of the atmosphere and helping to mitigate the warming of the climate. So we know that the amount that gets locked away in the soil is basically a balance between how much is getting pulled in through photosynthesis and locked and then exudated through roots to the microbes and then sequestered into soil aggregates. And this balance is mediated by those microbes in the soil and how much they're respiring back into the atmosphere. So that difference is the net carbon sequestration in the system. There are other greenhouse gases, however, that we need to account for, including methane, and importantly, nitrous oxide. So I mentioned before that nitrous oxide is a very important or powerful greenhouse gas. So nitrous oxide is produced by microbial utilization of nitrogen. And depending on the environmental conditions and the amount of nitrogen that we put on, we can have substantial emissions of nitrous oxide, even in organic systems. So it doesn't matter what the source of N is, this can end up back in the atmosphere if not used carefully. And this means that we need to account not just for the amount of carbon going in, but also these other important greenhouse gases. So when we look at this graph is showing the global warming potential of the different gases relative to carbon dioxide over different time horizons. So for methane is almost 100 times as powerful as carbon dioxide over the short time horizon of 20 years. Nitrous oxide, regardless of whether it's 20 or 100 years, is 273 times as powerful a greenhouse gas as carbon dioxide. So it's really important, even though it can be small amounts coming from our field, to understand the emissions. So if we were to calculate the overall balance, we would need to basically do some math to assess how much the methane and nitrous oxide are also contributing to the system's emissions. And we get, as a result, an equivalent of carbon dioxide out of that system. So over the course of the experiments that we've been running at UBC Farm, we've been using a combination of these automatic chambers which open and close over the course of the day and take gas samples that are coming off of the soil surface and sending them to a nearby instrument. And then we get a very nice picture of the day, the 24-hour emissions from these plots throughout the experimental field. And then we have undergraduate and graduate students who go out and in these smaller chambers, we take a portable instrument and measure the greenhouse gases at all of our experimental plots, either weekly or bi-weekly. And what we are able to do then is to get an emission profile for each of our treatments. So here we've got an example of the daily emissions of nitrous oxide. And you can see that right after we apply nutrients, we get a big spike of nitrous oxide emissions. And then interestingly, at the end of the season, when we go to harvest, we get another spike. And over time, we can basically use a linear relationship between the sampling points to develop a cumulative emission for each of the treatments. So there's a lot of information in this graph. I just want to show you that over the course of 3 years, we were measuring methane, carbon dioxide, and nitrous oxide for our 4 treatments: high compost, low compost plus nitrogen, and then our control. And you can see, if we focus down here on the nitrous oxide, that the emissions were relatively consistent, with a little bit of a change between the low compost and plus N and the high compost. And in one case, we had a situation where the low compost was similar in our nitrous oxide emissions. Ultimately, when we converted these to carbon dioxide equivalents, over the 3 years, we saw a cumulative nitrous oxide emission that was significantly higher in our high compost than the low compost treatments, showing that this in fact results in much more global warming impact than low compost treatment. And that although it's not significantly different between the high compost and low compost, we are showing some reduction, and certainly substantially higher than the control. And what's important to recognize is that although many farmers that we work with see applying as much compost as possible as an important way to build up soil organic matter and potentially sequester carbon, these numbers over 3 years are showing us that we are equivalent to our sequestration rate over a 1-year period. So basically, if we are doing the math on the nitrous oxide emissions, we could quickly surpass the amount of carbon that we can sequester in our soils. And then a final thing to consider is really the life cycle and of moving compost around the region. So we're getting compost from over an hour away to get to our farm at UBC. And those nutrients that are going into the compost are largely being sourced from manure, from feed that is inevitably coming from other provinces. So the closest that it's possible that we could be getting our feed source is probably neighboring Alberta. So we've got nutrients in the form of feed coming to our compost facilities. And then there's all the ghost acres, the acres that are in production, and the nitrous oxide and the carbon balance that are in those farms that we need to think about. So I want to wrap it up here. I want to put into context the regenerative agricultural outcomes that we're expecting from our organic agriculture in terms of maintaining soil health, reducing impact on the environment, increasing the resilience of the farm and profitability, and sequestering carbon. So from our analysis, we show that more compost does not necessarily mean more regenerative. High application rates are actually resulting in more nitrous oxide rates. And clearly, if we're not matching the P demand of the crop, that we're increasing that phosphorus pool and possibly creating environmental risk. So what is really needed, I think, in organic production systems is figuring out how we grow more nitrogen on site. We need to figure out how to cycle more nutrients close to the farm. And this is going to be a challenge that will vary enormously depending on the region. And I'm hoping that we can work with some of the innovators out there right now who are working on novel sources of nutrients. So some of those might be seaweed or other recycled nutrients from urban areas. And then a huge area of research would be enhancing soil biota. So we're doing more with the nutrients that are currently in our system. And then finally, if you're interested in any of the outcomes of these studies, they're all posted on the BC Food Web. If you Google BC Food Web and look up the Sustainable Agricultural and Landscapes Lab, many of these studies have fact sheets that are associated with them, as well as master's and PhD theses. And then all of these studies are posted on our lab website. Okay, I'm going to stop sharing, and I don't think I left much time, unfortunately, for questions. Sorry.
That's all right. Thank you, Sean, for a very informative presentation. Maybe what we'll do is we'll just go over 1 or 2 questions so we can kind of stay on schedule, and then we can bring some of the other questions to the networking session in a bit here to follow the last presentation. So the first one that I'm going to share is, thanks, Sean. Your project clearly demonstrates the trade-offs between soil building with compost and XSP. Many of the Saskatchewan soils are lower in P and have high soil pH. Do you think XSP would be an immediate concern?
Yeah, no, and I probably didn't frame this well, but I think the 3 regions that we worked in illustrated sort of that the range of available phosphorus in our soils inherently. And yeah, I think the buildup of phosphorus is a concern in some regions, but in other regions, it's the lack of phosphorus that's the main concern. So figuring out how to get phosphorus to the soils in Vancouver Island is actually a big challenge. So yeah, I think that what I would like people to walk away from this talk with is the idea of trying to figure out that balance, making sure that they're doing the nutrient management planning and incorporating the crop demand for both nitrogen, phosphorus, and other nutrients in their application approaches or their soil management approaches.
Okay, thank you. The next question here, I'm kind of just going in order. I see a couple more coming in. What are the numbers, the count of nitrous oxide in a forest floor or the ocean? How does that compare to your farming study? Thanks. And this is in regard to microbes.
Yeah, I don't know offhand, but agriculture is the biggest source of nitrous oxide emissions in the Canadian greenhouse gas profile, as well as in BC's profile. So I don't know how they compare to those other systems, but they are an important source. That said, agriculture altogether for Canada represents only 10% of the emission profile, and in BC only 4%. That, however, is likely to change as other sectors start to meet their emission targets. Our part of the emissions pie is likely to go up quite rapidly. So we need to be proactive and help contribute to our zero emission objective by 2015.
Okay. Deb, maybe I can ask you to jump in here. I know we have a couple more questions, so just whether you want to introduce the next speaker and how you want to approach that.
Oh, sure. I think maybe we could take one more question and then move on to Kat.
Okay, perfect. So again, just moving down the list. When we are applying nutrients to maintain good high yields, we are applying nutrients to maintain good high yields, but we also have the issues associated with higher nutrient inputs. If you are starting to build a nutrient management plan for a new vegetable farm, how would you start your planning?
That's a really good question. I mean, I think it's important to know what's in the soil. It's important to know what nutrient options are out there. So one of the outcomes of this study was clearly that even within the various regions across the province, there was a high variability in the nutrient profiles of the compost that were available. So, you know, it may mean that you need to do a little bit of homework, sleuthing the nutrient sources, the composts that best meet your nutrient demands of your crop. And then, yeah, I think there's certainly the evaluation of what your organic matter levels are relative to other soils in your region, and trying to get up to an organic matter content that is yeah, at par with what you're seeing across that region, so that you're maximizing the cycling of nutrients within your system.
Okay. Well, thanks, Sean, and thanks again for your presentation.
Yeah, well, thanks for having me.
We really appreciate it.
All right, yes, thank you very much for joining us today, Sean. And last but certainly not least, we are pleased to welcome our next guest speaker, organic producer Ken Lang, who is here to share his experiences with no-till in organic vegetable production on his farm in Ontario. So I'm going to stop sharing and welcome Ken and turn it over to you.
Okay, am I up there?
Yes, you are. Looks great.
Okay, so the last 3 years I've been part of the Living Labs project, which is funded by Agriculture and Agri-Food Canada, and I was one of the host farms for the Ecological Farmers of Ontario. I was the horticulture site. They also had a field crop site. Okay. So I farm along with my wife, Martha. We've been farming where we are now for about 40 plus years. The first 20 years, we were a small fruit pick your own farm. And the last 20 or so years, we were vegetable producers, which marketed through a CSA. In the last few years, our daughter came on to help us manage the vegetable operation. So just to give you some idea, we're a long ways from Saskatchewan. We're along the north shore of Lake Erie, about halfway between Windsor and Fort Erie, just a few miles from the lake. So it has quite an impact on our microclimate. And we sit up on a ridge, an old moraine near the shore of what used to be a much larger glacial lake. So down at the bottom of our farm, there's beautiful sandy loam soil, no stones, beautiful area to grow vegetables. This is just to remind me that it was a Living Labs project, and it was organized through the Ecological Farmers. And one of the things was a result of farming for so many years was that we've been organic farmers for 30 plus years, realizing that tillage is a major problem with organic farms. We till to transition from one crop to another. We till to prepare a seed bed, and we till to control weeds. So my objective in this Living Labs project was to develop no-till strategies for vegetable crops. And we were trying to avoid the use of agricultural plastics. And it was a mechanized tractor-based system based on a 60-inch bed system, which is sort of typical of a mid-scale market garden. And in these plots, you'll see pictures of, there was no hand or mechanical weeding during the growing season. So the weed control you see is what was there. And it was a 3-year project. For the first 2 years, it was basically a sort of a wide-ranging survey to look for promising techniques. And the 3rd year, we switched to replicated side-by-side plots of garlic and potatoes. So the different techniques we used, we tried deep compost mulch, which is often used on smaller scale organic farms. So we're using about 2 inches of compost, and sometimes we used it on tilled soil, sometimes on winter-killed cover crops or rolled cover crops. And in our case, we used spent mushroom compost, which is relatively available, about $35 a ton, but 2 inches of compost represents about 100 tons per acre. So quite an expensive technique, and the crop would have to match it with quite a large income. It does give you good weed control, but you do have to be careful because in my case, the spent mushroom compost was stockpiled at a dealer's farm on soil. And if you got down to the bottom of the pile and he loaded some soil, it usually had weed seeds in it. And on my farm, if the spent mushroom compost was dumped on a field soil, and when we were gathering up, if we got some soil, we would experience some weed problems from that as well. And of course, they had lots of nutrients in the compost to grow those weeds quite large. So, but by and large, the weed control was quite good. It also acts as a mulch to conserve moisture, and it supplies quite a large amount of nutrients to the crop. So we also used winter-killed cover crops, so sorghum or millet. They're both sort of full season cover crops. In our area, they would need to be planted sort of early June, mid-June. And sometimes we combine those with a legume like sun hemp or cowpeas. And sometimes we grew daikon radish by itself, but the extent of weed control in the spring is very short. And then we roller crimped various overwintering cover crops like rye and hairy vetch by itself, or crimson clover by itself. And sometimes we used a termination strategy of flail mowing, obviously before transplants, but you have the option in the case where it's seeded, you can do it after or before seeding. And those crops were like rye and hairy vetch and pearl millet and cowpeas. So one of our most promising no-till techniques was with potatoes. There's been lots of work done where cover crops are grown before and after potatoes, but it seems like very few people have decided, let's just leave the rye there, plant into it in the spring. So here we have, this is actually an RJ no-till carousel type transplanter that we actually planted the potatoes with. We're planting it into rye, a rye that has a little vetch. There wasn't much vetch in the mixture, but planting right into it. This is probably about late April in our area. And this is another planting time, probably early May. You can see the rye is growing up a little taller. And as soon as the first, I did want to say, we were using a variety of potatoes. We call it Orchard Hill Rose. It's not actually officially named yet, but it was a result of a Bought a Seed initiative selection back in 2016 on our farm. And we were looking for a variety of potatoes that was highly resistant to potato leafhopper. You can see in this field here, some of the varieties look like they're dying back or suffering from late blight, but that's actually leafhopper damage. And this Orchard Hill Rose is quite resistant. We were given about 50 tubers from Dwayne Falk's breeding program. And I think we were very lucky to find such a resistant variety with such a small selection. Anyways, it was the variety we used in these no-till trials. It's also very productive, fairly high yielding. So just when the potatoes start to emerge, they don't emerge very evenly. So there's always a first few ones that will indicate when it's time to terminate the rye. Then we come in and flail mow off the rye and hairy vetch. It's a heavy-duty flail mower. Can easily chop up all that rye residue and deposit it evenly across the bed. And it's sort of interesting here, we have a bed of hairy vetch beside it. It doesn't look like it's blooming yet, so you can tell that the termination times for these are not entirely coincide with each other, which can be a bit of a problem if they're grown together. So here we are. This is sometime in June, quite a good emergence of potatoes. They're in 2 rows, like sort of twin rows in a 60-inch bed. The rows are about 24, 26 inches apart, and the potatoes were planted about 12 inches spaced in the row. But quite good weed control, quite a good mulch of rye. As long as you can't see bare soil between the residue, you probably have pretty good weed control. And there we are, very near to harvest time. The potatoes plants are dying off, senescing. And we probably harvested this plot the next year, and even or the next day. You can see from these plots, no hand weeding, no mechanical weed control. There are a few weeds along the edge, probably outside the plot, but quite good weed control. And here we are digging probably the next day in the case of that previous slide. So this is the Orchard Hill Rose variety. You can see quite a heavy yield here. And we were able to dig it with this fairly simple potato digger. We did have to make some modifications to that digger. It usually just has a straight bar across here, and it wouldn't penetrate the very firm soil. We had to add these carrot plates, which are an option from the manufacturer. And we added these hilling discs on the side to cut through the residue and prevent plants from hanging up on the 2 sides of the potato digger. And here are the yields from those plots. So quite a good yield well over 35,000 pounds per acre, which is well over the 5-year Ontario average, more typical of PEI, Manitoba or Alberta yields. But you'll see here the early harvest didn't have any greening, but a month later, we did have some problems with greening. These are the tubers at the surface. They've been exposed to the light and they will begin to turn green, which makes them unmarketable. And we did have a 4-inch rainfall event between these two harvest dates, and also these later harvest, we had mowed off the tops. So both of those things may have exposed it to the light and caused the greening. And of course, you probably would have noticed with potatoes that digging any root crop is a major tillage event. So this isn't a continuous no-till system, but it's certainly, you've had either growing rye or rye residue on the ground for a whole year, which is quite an advancement. One of the other things we noticed in 2022 was the difference in the activities or passes across the field. We had tilled organic potatoes, a lot of passes for weed control, and 2 for Colorado potato beetle with entrust or spinosad. And in the no-till, it was down to 7 passes. And actually, I noticed we counted the irrigations in here. It was irrigated twice. That wasn't really so much a pass across the field as these were a fairly large scale sprinkler irrigations. Another crop we tried was no-till garlic. Here you're sacrificing a whole harvest or a whole growing season before the garlic season because you've got to produce a lot of biomass from a winter killed cover crop, either of pearl millet or sorghum Sudan grass. These are very growthy cover crops, and as they get 3 to 4 feet tall, you can mow them and they will regrow again. And if you plant it early enough, you can probably mow it twice during the growing season and produce a lot of biomass. But that's what you're depending on for the next year for your weed control. So here we are. This is in the fall, probably early October. We're planting garlic into a plot that's had flail mowed sorghum Sudan grass on it. And again, it's this RJ carousel no-till transplanter. It has been modified a bit to enable it to plant garlic. One of the big modifications was put a little flap on the back of this planting shoe. Otherwise, the garlic cloves would come flying down here, hit this blue thing or the side of the planting shoe and just pop out the back and not be spaced properly. This blue thing here moves back and forth to shove out the garlic or the transplants at the required spacing, and it's controlled by a series of sprockets and chains. Here we are, some plots that were planted in the fall of 2020 into sorghum Sudan residue on this part and millet over here. And this is April of next year. So we have 4 rows in each 60-inch bed, so they're 12 inches apart. And the garlic was about 5 to 6 inches apart in the row. And at harvest time, still quite reasonable weed control. Of course, garlic is a relatively short season crop because we're harvesting probably the middle of July to the 3rd week of July. And the yield is quite good in those plots, approaching 11,000 pounds per acre. This field, this AC field, was on a sandy loam soil, pretty good average size bulb. And up on a clay loam soil in a different part of the farm, the yield dropped down a bit, but still quite reasonable for a no-till garlic. And here's just a different planting situation. This is pearl millet, and then cowpeas. They sort of look like soybeans, but they'll actually climb right up the stalks of the taller cover crop. And of course, it hasn't been mowed because the mowing during the season would have terminated the cowpeas. So we let it grow for the whole season, and we're planting it into it standing to avoid too much residue on the ground to plant through. And another crop was winter squash. And in this case, we're rolling the cover crop to terminate it. And this is a short line manufactured roller crimper by the Yetter company. It just happens to be 60 inches wide, the width of our beds. So that's why we used that. And it was quite simple just to clamp it onto the forks on this pallet attachment on the loader. And here we are rolling a rye vetch cover crop. You can see quite a bit of vetch in there. Vetch you want about half bloom, and the rye should be shedding pollen fairly late in the bloom of the rye. And here we have, we've just transplanted a row of squash. This is a variety, a butternut variety called butterscotch. It was chosen because it's not quite, it doesn't have very long vines, so the vines would sort of stay within our 5-foot beds. So this purple vetch, or it's actually hairy vetch, purple vetch, a different variety, a wild variety, was rolled just the day before, and we have come through here with our transplanter and planted those plants. We also planted some into a deep compost mulch on top of a rolled cover crop, and this is just the machine we used. It's a PTO spreader that's got a baffle on the back, so it just spreads it over the bed. And by varying the speed of the tractor and the speed of the bed chain on the spreader, you can manage to get the thickness of compost that you want. And here we have two rows of squash planted into rolled rye and vetch, and then over here these squash were transplanted into just hairy vetch by itself. So you can see that the hairy vetch was much more friendly to the squash plants than the rye. Whether it's the allelopathy or the tie-up of nutrients, and particularly nitrogen, that affected these squash plants, we don't really know, but there were some plants missing. And it's quite a challenge with a no-till transplanter to open a trench, drop in a tapered plug, and then get that trench closed behind it. Sometimes I think they are just contacting on two sides of the plug, and some of the plants will die because they're drying out or struggling. But and just some the results. The rye, planting into the rye, relatively low yield reflected in those poor plants, and then planting into hairy vetch, we more than doubled the yield. And then if we use deep compost mulch, there was another big jump in the yield with winter squash. Just a picture of this big no-till transplanter. You can see this, it has a row cleaner mounted up here. If you've got too much residue, you can set this. It's sort of a floating device. You can sort of adjust it to just sweep away part of the residue. You certainly don't want to create bare soil because that's going to create weed problems. Then it has a very large wavy coulter to cut through all the residue, and then double disc openers in front of the shoe, and then closing wheels. These wide closing wheels were really for bare soil. We used narrower ones, and then we even had built some spoked ones or crumbler type closing wheels to try to get that trench closed. So here's a close up where I think this is actually was oats and peas. We tried as a spring grown cover crop, and this is actually a fixed row cleaner that we that we tried at one point, but it either tended to because the ground is uneven, it will either dig a trench or miss the residue altogether. And sometimes with some crops you can put a shank to do some subsurface tillage right behind your big wavy coulter. It was more commonly used for potatoes. And there's a close-up of the floating row cover. So it has those aluminum wheels mounted on the spoked wheels to keep them from going too deep. And it's hinged so that it will ride up and down with the undulations of the soil. And another shot of this machine working in oats and peas that had been terminated with the roller crimper. We're actually planting sweet corn into that, but it didn't work very well. It was quite late by the time we'd waited for the oats and peas to get to termination stage, even though they were planted very early in the spring. It was too late in the season for good sweet corn growth. And here's the crumbler type wheels. They have these little pointed fingers on the circumference, so it tends to poke the soil back around the transplants and closes the trench better. And we also tried transplanting tomatoes. These were paste type tomatoes, a very late blight resistant variety. Plum Regal, I believe the variety name was, because if we plant susceptible tomatoes outdoors, they will usually succumb to late blight before we harvest the full crop. So our normal tomatoes that are susceptible to late blight are all grown in high tunnels. And you can see with these tomatoes a few missing plants. They also struggled initially, but they finally got going. Tomatoes very tough, and they actually produced a decent crop. And you can see the weed control is quite good with that residue of rye, and there was probably a bit of vetch in it as well. So here's late in the season, just to give you some idea of the yield. We didn't record the yield, but there's a lot of tomatoes on those vines. And that's it. We can have some questions.
Great, thank you very much, Ken. Great to see what you were doing on your farm and all of your interesting equipment there. Speaking of the equipment, one person wanted to have you repeat where you got that crimper again?
It's a short line company called Yetter, Y-E-T-T-E-R. And they produce a lot of machinery for no-till planters, like all sorts of coulters and fertilizer injectors and that sort of thing.
Okay, great. And then this one is just a comment. Loved seeing your farm with the U of S a few years ago. Tried pumpkins in rolled rye and had the same effect, where the plants never thrived. Yeah, and it is interesting about the rye and whether it's the allelopathy or whatnot. Rye is a popular cover crop here in Saskatchewan, but did you have a cover crop that in your experience performed the best, or that you liked the best?
Well, it's sort of a trade-off. Rye produces a lot of biomass and gives you a lot of residue on the soil to control weeds. Hairy vetch, I think, certainly was a second, and of course it's a legume, so it's fixing nitrogen. The residue probably doesn't last quite as long, but it seems to last long enough in the squash trials, and of course they're there for the full season. The winter killed cover crops like sorghum, sudan grass, and millet will last quite a while, but usually, I don't know, by the middle of July, end of July, the weed control is breaking down in it because it's been, it was winter killed and then it had a long time to break down. And there's the whole issue of whether when you start mixing legumes with, carbonaceous cover crops, whether they accelerate the breakdown. We had some trouble in 2022 with the rye vetch combination breaking down a little early in the season, and we had quite a bit higher proportion of hairy vetch in the rye in 2022. So we weren't sure whether it was the extra nitrogen that was contributing to that breakdown. Also, your termination strategy also can affect the breakdown. If you're flail mowing, it breaks things up into small pieces and then they break down more rapidly. So that can have an effect as well.
Okay, good to know. Any issues with weeds? For example, if you didn't get enough mulch from the cover?
Sure. You really have to expend quite a bit of effort and skill at growing a good cover crop. It wants to be, don't skimp on the seeding rate, use a high seeding rate, get the fertility there. And in these organic no-till strategies, most of the fertility has to be there before the cover crop because you don't have an opportunity to till it in, at planting time. And side dressing is problematic when you've got all that residue on the ground. So yeah, you got to put as much management into growing the cover crop as you do the cash crop because it's so critical to good weed control. And we certainly had some plots where there were weeds. If you didn't have enough residue, or if the cover crop was breaking down too early in the season, or something like daikon, where really it's broken down almost completely by spring and you're planting into almost bare ground. So the weed control effect of cover crops like that do not last very long.
Okay. Someone was curious if you've ever tried buckwheat before garlic in specific.
Not in a no-till situation. I mean, we certainly use lots of buckwheat as a cover crop to prepare vegetable fields the year before. I've not had good experience where I've left buckwheat over the winter. It really doesn't have enough residue. It's a very succulent plant, breaks down very quickly. So I wouldn't expect much weed control from it the next year because it's just too much bare soil showing.
Right, okay. Any experience with Phacelia, either alone or in a mix?
No, it's one I've never grown.
Okay, what is your annual moisture?
We have 30 some inches of rain a year. Sort of on average, it's pretty evenly distributed over all 12 months, but we can have various drought periods in the summer. Last year it was about 3 weeks long, which isn't too bad, but it can be longer on occasion.
Okay. In Saskatchewan, we have 200 to 400 lower growing degree days than you have, and much drier conditions. How do you think that would affect the management?
Well, it's certainly going to affect the crops you grow. The mulching effect of most of these residues on the ground, I guess it depends. Some growers are worried that rye left too late pumps a lot of moisture out of the ground just by transpiring. I've never really had that problem because we usually start out with plenty of moisture in the spring. So laying down, all that rye residue or other cover crop residue tends to conserve the moisture. But we still irrigated when we needed to. I think the potato plots in 21 were irrigated twice. And the plots this past season were maybe irrigated just once because we didn't really have any serious dry periods. But.
Okay, great. Oh, another one came in. When do your cover crops go in?
Okay, so the rye and vetch would normally be planted about September 1st of the previous year. Daikon radish, probably more like the middle of August, and pearl millet, sorghum sandgrass, early June, probably preferable. By the time you get to July 1st, you're not going to get as much growth. And of course, if you're mixing things in like cowpeas and sun hemp, which are pretty warm season, just like millet and sorghum, they need to be in early as well.
Great. Thank you very much. Well, unless there are any other questions that come in the next second, which one did? Thank you. Do you plant any spring cover crops?
Yeah, we tried oats and peas as a spring cover crop, and we even, no-tilled it into daikon radish cover crop. Of course, that had winter killed, lets us in really early because it's a strategy we've used for planting spring cereals early, is just to no-till them into daikon radish fields. But it's still, you need about 90 days. So it made, either seeding or transplanting into that too late. We just tried it the 1 year, but it really seemed to shift the growing season way too late to get good production.
All right. Okay. Perfect. Well, thank you very much, Ken. I think that's the last question that we have here. So just thanks again very much for sharing your experiences with the group today. And to any of the other speakers that are still on, just to thank them once again for taking the time to present to this group today. So we have a networking section built into this program here. So I think I'm going to turn it over to my colleagues again, Macy and Andy, to kind of introduce this next section here.
All right. So thank you, everyone. I think we've been asking lots of good questions throughout the whole day event here. We've created some questions to get conversation going, but of course, welcome any other questions that might come up and just an opportunity for us all to chat with one another. So I believe Deb is going to unmute everyone and we have the opportunity to chat using the audio, or we can still use the chat function on the side.
And we encourage everyone to put their hands up at the bottom of the screen so that you'd look under the reactions tab and there's a raise hand option. And that will allow us to maintain some order, but don't all put all your hands up at once. So I think to get things going, we had some great discussion and presentations, and not all of the speakers were able to stick around. But if you have more questions for Ken or Tiara, and I'm not sure if who else of our speakers are still there, but yeah, go ahead. Is that Pangaj?
Hi. Yes, my name is Pankaj Bhomik. I'm with the National Research Council here in Saskatoon. So this is my first meeting and I found it's very, very useful, informative information. And I appreciate Jody from Sask Fruit and Vegetables, forwarding the link. And this is my first webinar or learning, the vegetable, organic vegetable, the production and growing aspects. So when I put, even I do, as Dr. Zhang mentioned, I do have personal interest as well, have fun growing on my own different vegetables. So when I put my researcher hats, the question I have through this, association or organic vegetables associations, that in terms of R&D or research aspects, the identifying the gaps, how do you run, or do you have any program, or annual program or cluster that you participate or encourage your producers to provide their input, so that the R&D aspect is also directed towards the achieving the goal that will eventually help the producers, right? So that's the piece, right? When I go to other producer group annual meeting or join, I hear, from them, okay, last year we had this disease, fusarium issues or drought issues, and then we would like to see, new varieties, or we would like to see disease control or agronomic management that will help us to address that, the challenges, of growing. So I was trying to come from that angle. You may have a different mechanisms, but that's my question. If you can, help me to understand or guide me for more information, that will be very helpful.
Perhaps I can start with that one. So I think every part of the country, organic agriculture is so diverse, and the growing environments are so variable, and there's grower networks and organic grower networks across the country. So on the prairies, there'd be less discussion perhaps on vegetables, and that's why these sessions are being held. But certainly in BC, Ontario, Quebec, and in the Atlantic Canada, vegetable production systems are discussed quite routinely, and there's producer organizations and conferences where things are discussed. the Organic Agriculture Centre of Canada, along with the Organic Federation of Canada, co-manage the National Organic Science Cluster. I put the link into the chat just now, so you can pull it up. And so we are part of the National Science Clusters Initiative, and there's the one that's focused on organic. There's a number of research projects that are vegetable oriented, and greenhouse and field systems. In terms of priority setting, certainly the industry connection with the researchers is extremely important when we put out the call for proposals for the science clusters. Having a strong relationship with researchers and researchers with industry is extremely important, because that's what informs strong proposal writing that could have impact. We went through a national process of gathering research priorities before we submitted our science cluster application. And we do that every 5 years when the cluster application is going in. But many provinces, they do their own research needs assessments more frequently. And so I know Sask Organics has done it, and Alberta has done it, in Quebec. And so there's a variety of mechanisms for getting what the research priorities are. Anybody else want to supplement that?
Yeah, I can just add, you touched on it, Andy. Sask Organics conducted a research priorities report. I believe the last one we did was actually in 2019 with our members, but it was a pretty comprehensive survey that we conducted among our members, and we did it in conjunction with the Saskatchewan Ministry of Agriculture, actually. And we still reference that report in quite a bit of the work that we do, especially when kind of evaluating different research projects and things that are being done that might be applicable to our members.
And
So
thanks,
I can
Casey,
access
for correcting my link.
Yes, sorry. Yeah, the link I was also trying. So I can access that on your website?
Yes.
report?
So, yeah. And on our website, we also have the Organic Science Canada magazine. And if you're having trouble finding it, it's under our Science Cluster 3 and New Resources page. And sign up for our newsletter, and you'll get updates with any new technical bulletins and whatnot that come out. One of our more recent ones was on biochar. We've had ones on green manures and coupling green manures with poultry manure as well. So as far as the rest of this discussion, this networking session goes, you've heard lots of comments from the speakers, and certainly you're welcome to ask more questions of the speakers. But we're also interested in hearing from you, and if there are key experiences that you've had in organic vegetable production, what are the most important lessons that you've learned from a prairie growing environment perspective? Or what resources are really needed? Where are the gaps? Like where can groups like Sask Organics or maybe the OACC help you more in providing you with resources? So any thoughts on that? Anybody want to jump in and let us know what you're thinking?
Well, with cover cropping in my location, we get about 15 inches of precipitation a year, and it generally stops in the middle of July or somewhere before. So you get no precipitation from middle of July to the end of the season, more or less. So cover cropping, the way that I've tried it, just hasn't worked, because if your crop is growing, your cover crop is growing, your vegetables also should be growing. So one thing I'd like to see is a cover crop that's actually workable in the prairies. I haven't seen it yet, because you basically, you have to plant it in the spring, and then it's one full 12-month year before you can use the bed again. So
yeah. Anybody want to comment on that? I don't know if Ken has any insights on different cover crops or
Well, I
Tiara.
think
Yeah.
we don't suffer from such dry conditions, and that's a real challenge. You might have to look at something that's, very drought tolerant, and I would suspect that some of the millets might be fall into that category because they're grown in areas with much less rainfall.
Do you think corn could do if you used cheap corn and didn't let it grow for very long?
I've never tried corn. I think millet's pretty rugged, and I have no idea what it would grow like out in the prairies. But it would certainly be worth a try, I would think.
Whereabouts are you, Andrew?
Midway between Calgary and Red Deer.
Right.
So yeah, last year it stopped raining on July 5th, and we got no precipitation until November 1st, I think. So
Andrew, do you not irrigate your vegetable crops?
the ones that have to be, I do, but otherwise it's not quite realistic for me to irrigate them. So it's just survival of the fittest. So it becomes very, very varietal dependent. And believe it or not, some stuff does great. A lot of stuff does terrible, but you just try and learn, right? But when I say some stuff does great, some stuff does really well. So you wouldn't expect it. But I think that's why this area is so good for grain, because it grows up nice in the spring and then dries down well for the fall harvest, right? So.
And what were you looking for in terms of a cover crop? Like what specifically are you trying to get out of it?
Well, in particular, the soil here is, if it's tilled too much, if it's tilled much, really, it goes hard as concrete when it dries out. And so some way of keeping the soil moisture in and keeping it from hardening up. So believe it or not, something that I found to be absolutely amazing for covering the ground, if you can keep control of it, is just your pigweed, right? Like if you keep your pigweed about 6 inches high and not let it go to seed, which is difficult, it's fantastic for keeping the soil moisture up and the soil friable. But the biggest difficulty here is just keeping the moisture in the ground so that it can maintain friability. Otherwise, it really does set up like concrete.
Yeah, definitely a challenge. And so I've I guess from the perspective of creating a mulch type cover, using some of the cereals does have some of that, and it won't break down as quickly, but you don't get the nitrogen benefits from it. I've had some successes and some failures when I worked with fall rye as well, in a little bit lower moisture conditions, but also lower fertility conditions. The experience was that if I didn't have adequate fertility to support the rye crop, the fall rye, that it was too thin, and then you didn't really get enough mulch to support good weed control. And I think Martin Hentz found that as well in a bunch of his work out in Manitoba, that can't remember the exact number, I think it was in the order of 6 tons per hectare of biomass that was needed to basically a good 2 or 3 inch layer of mulch to suppress weeds adequately. Mm-hmm. And I found that a nitrogen deficiency did not provide support enough rye biomass to really control weeds sometimes. So I don't know if Ken, you've had experiences like that.
Well, yeah, I was just going to suggest, would hairy vetch, it would survive on the prairies. It's quite winter hardy, and it's also sort of what I call a winter annual. Like, it's not a perennial. So once it flowers, you don't really want it to set seed. You might want to terminate it early, but the rye as well. But if you grew the two together, would that help?
Yeah, I don't know. Like,
yeah.
These would be things to try. Like, I've talking about the presumed allelopathic aspect of the rye. I did grow squash underneath a heavy wheat straw mulch, actually organic, so it didn't have graze on it or anything. And believe it or not, that actually did pretty similar to what you were talking about with the rye, and that was just with the straw on the ground. So I can't draw any conclusion from that, but I did observe that the squash didn't do well underneath straw. It did well underneath other types of mulch, but not underneath wheat straw. So go figure. I had thought about actually just growing peas as a cover crop and just rolling them down and planting through peas, because they seem to work well for that. But like I say, I don't know. I've been trying to figure it out. I've tried various things and most of them haven't worked. So
Andrew, I just want to let you know, and I'll share a link to it at the end here, but we're teaming up with, and I believe Andrew is going to be speaking at it, if I'm not mistaken, Andy, but on April 5th, there will be a cover cropping on the Prairie's workshop. It'll be online, and it's led by Dr. Miriam Fernandez. She's the organic researcher at the Swift Current Research and Development Center, and so they have a bunch of organic trials there, and they have cover cropping, intercropping, living mulch trials, and Swift Current is definitely a dry area. I believe it's in the Palliser Triangle, which is one of the driest places in the country. And that'll be a free event, and it's online. So if you're interested in that, I'll show you a link at the end here before we end the meeting.
for sure.
Yep. Andrew, you were mentioning, like, were you wanting to plant into the cover crop like in the middle of the summer? Was that?
Well, no, like what I'm saying is that I can't get cover crops to work. The only thing that I've been able to get to work here as a rule is totally conventional, except for I did notice good results in a plot where somebody had just kept planting peas on it and peas on it and peas on it, and they never took the vines down. They just rolled them flat and planted through them again, and that actually worked quite well. But that's the only thing that I've seen. Otherwise, you have to clean the soil off, and it's just a total nuisance. So yeah,
some of Martin Ence's work, you must be either dark brown or black soil zone.
dark brown.
Dark brown, yeah. And Martin's work out in Manitoba is obviously in the black soil zone, so a little bit wetter conditions there. But he's done mixes of with hairy vetch, but he also has done like a variety of mixed cover crops, including like a oats, barley, peas kind of roll down crop as well. So those sorts of little more drier condition tolerant crops, chickling vetch maybe. There's what is the forage pea that was developed out of Swift Current that was being developed as a cover crop. It might actually be in the resource that Tiara just pointed to that we had actually helped develop, which was the Green Manure Toolkit that's available on the Pivot and Grow website, and encourage you to take a look at that as well. But, yeah.
Well, one of the things that I have been thinking about, which I've not really ever heard addressed formally, is that winter is actually, I think, part of the growing season here. And I noticed that even when it's minus 310 with a foot of snow on the ground or 2 feet of snow on the ground, actually stuff still rots on the ground all winter. And so in the spring, it'll go down fresh. And by the time the snow's off, it's rotten and just about gone. So I don't know what conclusions to draw from that, other than I think that it would behoove me to pay attention to winter as part of the growing season, even though it's classically a totally dead season, because it's usually the only time of year where there's any water consistently as well, with the snow sitting on top. So like I say, I can't draw any conclusion from that yet, but it was something I observed. So
I have seen reports around soil biology that remains active underneath a mulch and providing it's not like totally frozen solid. When things get just even when you think it's quite cold, there can still be some biological activity happening and turning over of organic matter. But yeah, I see in your notes in the chat that you put that it's a heavy clay Chernozem. It's windy and it's alkaline, and so you must be talking pH 7.8 or something like that. And are you Estonian as well, or
No, there's not a
no,
rock.
it's clay.
There's not
It's
a rock
clay.
in it. Yeah.
Yeah, it's heavy clay. So
It's not heavy, but yeah, it's good soil. I'd say it's just about some of the best there is, honestly, and that's, I think, the only reason why anything grows here. So
yeah, well, it should have lots of potassium in it and some
yeah.
But yeah, certainly getting the organic matter up to maintain the good soil structure, it would be, I think, key. Any other comments, maybe for Andrew, or any other questions, successes, failures that you've had, things you'd like to share, resources that you need? Obviously, we need to have a drier version of a cover crop, which we'll talk about more in Miriam's workshop.
I just noticed someone commented in the chat here that they've been playing with some variations of cover crops near Prince Albert, Saskatchewan, not with vegetables, but it could be helpful in figuring out what cover crops stand a chance in that climate. They don't have results yet, unfortunately, but folks can follow on the conservationlearningcenter.com, and we'll see if some hairy vetch overwinters this spring. Thanks for sharing that.
Yeah, for sure.
Usually people don't want hairy vetch to overwinter. They're usually planting it in the spring and hoping it'll be dead by the following spring, because it can become, if it survives the winter, then it can be keep growing and be really problematic for some crops. Now, I don't know, Ken, do you have anything like, typically does hairy vetch survive the winter for you, or how do you manage that?
Yes, hairy vetch will survive here. And yeah, if I was a grain grower, I wouldn't want to grow it on my farm, because I've seen it wasn't hairy vetch, probably it might have been just the common vetch or purple vetch, but if it gets into grain field, it makes an awful mess. It binds and ties it all together. So that's a problem. But there are some others that could, would reliably winter kill, like crimson clover. Sometimes it doesn't even, I think it's not considered terribly reliable here, even in Southern Ontario.
Yeah. Great. Any other comments? Like people want to share if there is one thing you got to do, a success story that you've had. Tiara, I'm interested in, like, with the participatory plant breeding, you've obviously been working on a wide range of different soil types and soil conditions. And so how much have these different environments really influenced the kinds of genetics or crops that are being selected? Do you see a lot of that?
Yeah, that's something where for the carrot trials this past year, and hopefully this upcoming year, we're going to be using more quantitative data, so measuring, I think doing more specific data on soil health and climates to get more, a better understanding of that genetics and environment, because what we have right now is mostly that east and west, which is pretty broad, but we'll definitely see in this next iteration. And that's why we want a lot of feedback on what to do for the salad greens or leafy greens survey for this upcoming year, and selecting regionally adapted seeds or seeds that are grown in Canada to see if there's a difference in those genetics. Yeah. And just on Andrew's comment about cover crops, I know that's something we've recently talked about that at Organic Alberta, and we've definitely noticed a lot of the vegetable growers in Southern Alberta who are doing cover crops are using irrigation, and it doesn't we haven't found, we've mostly heard from other vegetable growers in the south that don't use irrigation. They're just hauling in manure, but I don't know if that totally solves your issues there, but it's definitely something we need to work on.
It's a funny one because a lot of the manure here comes out of feedlots, and it's so polluted that that it kills your garden. So it's more danger than, like, conventional fertilizer is safer than manure because of the herbicide pollution in the manure.
That's really interesting observation. With the participatory plant breeding, Tiara, I've always been fascinated, like if farmers are selecting the genetics and actually making selections and picking what works for them, they can be selecting on a wide range of characteristics. And I more so was in the field a little bit more with grain farmers when they're in the participatory plant breeding process, but different producers were looking at different plant characteristics, whether they're had a particular disease issue, or they might have had a need for straw for bedding, and so they're looking for longer stem length, or they're more focused on the head and the yield, and whether there's disease problems. And I'm sure that's the same with the vegetables, but there'd be also a lot more in terms of like the color and flavor, visual appeal aspects of the vegetables, which could all factor in, as well as the growing environment. So it's a very interesting exercise that you're going through. Okay, so does anybody else have anything that they would like to add, or questions that they'd like to ask? Challenges in vegetable production that they'd like to throw out?
I just wanted to, although I don't have a great answer for it, but someone in the chat asked if there was a resource to find organic compost or any compost at all in the Cypress Hills area. And I'm not aware of, we just don't really have access to that kind of data, unfortunately. At Sask Organics, I know of a few kind of input companies that sell organically approved compost or compost teas, but in terms of someone local in your area, I just don't know, unfortunately.
Yeah, and proper compost can be hard to come by as well. Like there's a difference between aged manure or just manure versus true compost. And I should say that there's another project that's happening with the Organic Science Cluster. That's a collaboration between University of Saskatchewan and AFC Lethbridge, looking at regenerating what factors result in soil degradation, perhaps under organic management, or how do we rejuvenate soils that are depleted. And so what are the keystone practices that lead to a truly sustainable organic farm? And so we're hoping to get the final report on that soon, and some more publications. And there's definitely compost integration into those trials. But yeah, a lot of interesting questions that are being raised here relating to especially the feedlot composts. Any other questions? Where do you market your vegetables, Andrew, if I may ask?
For myself, I'm more focused on seed than anything. I'm too remote to sell vegetables, so there's no point.
Okay.
And truthfully, the climate is so harsh that a lot of times the vegetables that come out aren't market grade. But for seed and for developing the varieties for seed, it's a lot better. So that's what I've paid attention to, is basically just finding stuff that grows and grows well. So cycling through varieties and taking notes and whatever else. Yeah. So like, for instance, you wouldn't think it, but I think I grew 8 types of peas last year. And like I say, we got no rain after July 5th. And one of the varieties did really well. One of them did pretty decent, and the rest of them were terrible. So that just kind of goes to show, right?
Yeah. Yeah, for sure. That's like a little stress to stimulate seed production too.
Yeah.
All right, Ken, do you use anything, like organically acceptable seed treatments, seed disinfectants or biostimulants or anything like that?
Very little. We did do EFAO. We cooperated with them and did a farmer-led research where we used sort of a bioinoculant and it had no effect. And we also, in that same, we had the plot split up, so we tried some molasses and fish emulsion as sort of a stimulant, because of course these were cereal grains planted very early, no-till, and the soil's cold, and we were trying to sort of stimulate them to germinate and grow early in the year. And there was no positive effect from either the bioinoculant or the molasses and fish emulsion. But I've been an organic farmer for 30 years. If I was transitioning land that was maybe sort of dead and didn't have a lot of biological activity, those things might work quite well to get you started.
Well, your no-till potatoes is particularly interesting because I've been scratching my head trying to think, how can a person do this, right? And so seeing that is actually encouraging to see that it can be done. It is being done, so it can be adapted from there.
Yeah, and I wasn't really the first one that thought of it. There was a researcher down in Virginia, the state of Virginia, Ron Morse. He was a university professor, researcher, and he did some of this work with no-till strategies for vegetables, and potatoes was one of the ones he was very successful with. But he did it 20 to 25 years ago, and everybody's ignored it. So that's where the idea came from.
And what's your soil pH, Ken? I'm sorry if I missed it earlier.
Oh, it's very neutral. 7's pretty common.
Yeah, because usually, like, if you start getting into higher pHs, then you start having scab issues, and so that's why PEI is so good at growing potatoes. They have more acidic soils and sandy soils, so the potatoes come out pretty clean. So I think a lot of it comes back to selecting crops that are suitable for your.
Yeah. I end up adding just elemental sulfur to my potatoes, and that got rid of the scab completely, actually.
Okay, that's good to know. We might have temporarily lost Andy for a minute there. Andy, can you hear us? No, I don't know. Are you still there, Macy? Oh, I wonder if something happened with the internet at where they are both located. Can everybody else still hear me?
I'm good.
Okay. Okay. All right. Well, I noticed that it is just after 12:30 here, and this was kind of the scheduled time for closing up the session. So I'm sorry that we lost Andy and Macy there for this last part. Maybe they'll join here before we wrap it up. Yeah, so I'll just go through a couple closing slides here before I close it off. Just to let you know of a couple upcoming events. This is our conference and trade show. It's happening for the first time in person this year. This event is definitely more centered around grain production, organic grain production on the prairies, but there's some livestock information as well. And then this is the one that I was telling you about there, Andrew. This is going to be an online workshop specific to cover cropping, and in Saskatchewan, in one of the driest parts of Saskatchewan yet. So the registration information will be coming soon. It's not up yet, but it will be free to attend, and just stay tuned to our website there, and you'll be able to get the link. And so at this point, I just want to thank all of our guest speakers again for their presentations today, and to thank you all for attending. It's great to get more interest in vegetable production, particularly on the prairies. I think it has, just endless room to grow here. And yeah, so just thanks again for attending. And you will receive an email within a day that includes the recording, as well as some resources, some sponsor resources, and then some of the resources that we highlighted or discussed today during today's session. And just once again, want to thank our sponsors, our gold sponsors, silver sponsors. And if you would like to get a hold of us or follow us on our social media, this is for both Sask Organics and the Organic Agriculture Centre of Canada. So with that, I'll just say thanks again, and I hope everybody has a great rest of your day.
Thanks, Deb.
See you later.
Thank you.
Thank you.
Thanks, everybody. Bye.